Tere tulemast kõigile ja hakkame siis oma seminariga peale. Minu nimi on Tõnu. Ma olen tänase ürituse moderaator. Me üritame siis tänast üritust läbi viia hübriidvormis, kus meil osad inimesed on olemas füüsiliselt siin seminariruumis ja siis osad inimesed peaksid meil olema samuti online'is. Ma loodan, et minu hääl online'i tuleb ilusti läbi ja ma paneksingi online'is olevatele inimestele südamele, et nii kui tekib mingi tehniline tõrge, palun andke sellest märku kohe siis kas chati või tehke kas või julgelt häält. Tundub, et kõik on hästi ja me jätkame. Tänase päeva teemaks siis on Autodeski poolt tootmisvaldkonna jaoks välja pakutavad lahendused. Ilmselgelt me saame rääkida mõnedest lahendustest, sellepärast et Autodeskil tooteid, tarkvaraprogramme, mida tööstuses kasutada saab, on mitmeid. Ilmselgelt on mitmeid ja tõenäoliselt olete nendest teadlikud ka, et täna me keskendume neist mõnele ainult tänase päeva jooksul. Räägime natuke päevaplaanist. Päevaplaan on meil selline, et loodan, et kava tuli kõigil ette. Et meil on enne lõunases sessioonis on meil 2 ettekannet, 2 kolleegi siis väljaspoolt Eestit jagavad oma kogemust erinevate Autodeski toodetega töötamisest. Mis järel on meil lõuna ja pärast lõunapausi siis on meil 2 ettekannet veel. Et ma paneks väga südamele, et me võiksime selle ürituse läbi viia, kuidas öelda, tõeliselt aktiivses formaadis, et võtke julgelt osa. Et ärme lase ainult ettekandjal rääkida, et iga ettekande lõpus saavad olema meil selline väike diskussioonivoor, et kasutame seda võimalust. Korraldusliku poole pealt ausalt öeldes on see kõik. Kas ma jätsin midagi tähelepannud, on teil mingeid küsimusi? Juhul kui küsimusi ei ole, we will switch to English because the first 2 presenters will do it in English. And I'm glad to say hello to Paul from England. Yes, you will introduce yourself. Yeah. As I understand, you are coming from a company which is also a part of the Future CAD group. So, please, Paul, take it over.
Thank you very much. Good morning, everybody. Okay, I just need to share my screen.
Yes, please click the button.
Yeah, I'm trying.
Okay.
Can you just...
I just need to...
Okay, so yes, my name is, I've got an echo.
Sorry.
Okay.
Can you switch off the sound, the speaker from your computer?
Yeah.
Yes.
How's that?
It sounds better. It's already sounds better. Yes.
And you'll love it when it goes technically smooth and professional. Anyway, yeah, so my name is Paul Tolley. I'm MFG Technical Sales Specialist. Just to give you some background, I've been involved in Autodesk environments for about 20 years, quite by accident. 20 years ago, there was a television program in the UK called Robot Wars, where you designed a robot to fight in an arena. My local reseller gave me a free copy of Inventor, a new piece of software that's came out. And 3 months later, we were in Robot Wars. I'd used Inventor to design the robot. We were ranked number 3 in the UK. And Autodesk, do you want to come and work for us? So 20 years later, here I am. So a bit of history there from me. So what we're going to be looking at is the manufacturing collection, and basically we get the same sort of areas of concern and questions from people using software, and they want to use it for design, engineering, production, sales and services, and there's always a module that can help you in those areas to move further forward and actually create things quicker, cheaper and smoother. And ultimately you've got the data management system, the Vault in the background, that's going to help you tremendously. So the questions we get asked frequently is, how can I spend more time innovating? How can we improve performance? How do we streamline manufacturing? And how can we win more business? Obviously, you don't want to spend time in front of your 3D CAD system just designing things and struggling. You want to be out there actually making things better, quicker and cheaper. So starting at the top, we have Inventor Professional, been going on obviously for many, many years, and it's a very top of the range 3D CAD system. But there's a lot of areas that people don't realize are actually there that can help you make things a little bit quicker and easier. And so you've got specialized areas for sheet metal, welded frame, tube and pipe. And also when it comes to the modeling process or the drawing process, rather than just having a fixed way of working, every time you have to create a parametric sketch, you have to extrude it, revolve it or whatever, we can now use the direct and freeform versions of modeling. So if you're used to using like Fusion, and I'm sure Rickard will be showing you more of this later on, you can actually work in the same type of era or same type of workflow by using the different modeling techniques. All clear so far? Everyone okay with my English? Tell me if I talk too fast. That's,
Your English is quite good, actually.
Thank you. Okay, so design automation, a very key thing here, because how many times you put together a very complicated assembly and someone says, that's exactly what I want, but I want it half the size, or I want it twice as wide. So traditionally, you'd go back literally to the drawing board, you would copy design perhaps, you would remodel components, you would swap them in and out. We've now got iLogic, and we've had it for quite a while built into the system. So we can actually use the parameters that you've used to create your model. So all of your dimensions, all of the revolves, the extrusions, they're all locked into a parameter. And iLogic can then access those parameters. And we can change the model on the fly. Now, working this all the way through, we can actually put up on via the Forge system, a web page, and your customer can actually configure their own assemblies and components and machines. Obviously, you've set up what they're allowed to change, what they're allowed to add and remove. But it takes all of the workload out from having to remodel the whole model every single time. Now, the first thing people say when you show them iLogic is, well, I don't know computer programming. You don't need to. iLogic has got what we call snippets built in. So we can drag and drop the snippet across, which gives us the code that we want to do. And all we have to do is change the parameters to suit our model. Makes life very, very easy. Just to give you an example of that. There we go. We've got a model on the screen here, quite complex. And what we're going to do is make some changes. So we're going to go to the editor. And we're just going to say, okay, well, what I want to do is change the size of the gripper. So we're looking at the parameter that's giving us the distance when we constrained the jaws. So on here, by just adding those in, we can bring up our window that we've created and just drag the slider within the parameters that we've preset now, and we can change the size of the components. We can then go a stage further. We actually create our own custom parameters. Now, this allows us to add, for example, a command that we're going to use for the holes. How many holes are in the backplate? And what materials are going to be made of? And these are additional parameters. They're not actually part of the model at the moment. We're just putting in whatever we need, and we're changing the unit type to either numerical or text. We can then add those changes into the iLogic script. And here you can see we're adding that parameter, so the number of holes that we added using the predefined snippet that we've dragged in from the left-hand side. And we're just going to say that equals holes. Holes was the name we gave the parameter. And then we're just going to say it's either going to be short, and we're going to change the size, and then also the length. So you can see it may look complicated, but once you actually see what's going on in the background, it's actually very, very easy to do. And the thing is, when you compare how long this is taking with how long it would take to completely remodel that assembly with different components for each version that we want. You're talking, this is minutes. You could be taking hours to do it the other way around. So once we finish that, we've got our commands, as it were, or our script. We can then add that to our window that we've created. And again, we can fully customize this. We can make it look a little bit more friendly. We can drag things around, change the tabs, change how many pages we got. And if you want to, you can even put a picture on there so your customer can actually see what it's going to be working with. So we're just going to drop in a JPEG just to make it look pretty. This could be your company logo if you're going to go to the next stage where you're going to be on the web. Let me just add in the material there. I must be talking quicker because I've normally done that bit by the time it gets there. So anyway, there we're going to choose whether we want sliders or text in here. So now when we open our control window, we've got the materials that we can change, the sizes, whether the backplate's got 4 holes, 6 holes, 8 holes. And again, you can see just by dragging those sliders around, using the drop downs that we used in the command, we can now completely reconfigure that assembly. Now, you imagine how many permutations we had there. How long would that take to remodel all of those to a different assembly? You're talking days, probably. This has took us minutes. So very, very easy to use and can save an awful lot of time. Interoperability is another big one. So particularly from Revit to Inventor. But previously, if you wanted to share a CAD file from AutoCAD, for example, you'd make it a DXF so other people can read it, which means you've lost all the integrity of the file. If you wanted to put an Inventor file into Revit, you'd have to put it out as a step or something like that. And again, you're losing the data that you've put into that component. So by using the AnyCAD system, we can literally bring in, for example, a Revit file into Inventor, use that in our Inventor model to position components, look for clash, which we're going to do in a second. And then you can push the Inventor model back to Revit. So any of these now change, the corresponding CAD package is also going to update. So if we make a change in Revit, the Inventor model or assembly that we've now got will also update. So you've got that bi-directional link between the files and the CAD packages. Here we've got an example where we've got a factory in Revit, and what we've done is done all the machine assembly in Inventor, and we just want to make sure that everything fits in. So the first thing we can do, just have a quick whiz round so you can see the size of the model. But we've got one bay that we've done all the machines for in Inventor, and we just want to place this in and see if it works. So what we now need to do is export our Revit model, just this area, the bay that we're working on, into Inventor, and then load the Inventor files to make sure there's no clashes. Again, very, very easy, all done on the cloud as well. We can share the file. This is our Inventor model. So that's the working bay with all the machinery that we want to put into our factory. And all we have to do now is import or place our Revit model. So we're not doing any modifications to the file type. We're not bringing in a converted file. This is the actual Revit file that we've just been looking at in Revit. So once we open that, it's going to give us a choice of the view that we want, because again, it's understanding the Revit views that we've selected. So we can have a little window that's going to pop up. We can use the drop down, and all of the views that we had in our Revit model are available for us to bring through into Inventor. So we're just going to go for our simplified version. So we don't need the entire factory. We just need the work area or the cell that we're working in. Once that comes in, we're just going to constrain that to the 0, 0, 0 point in the CAD model. So we've got continuity of the placement of the two components. And again, it's very easy. It's just a right click, place on the 0, 0, 0. That's now going to be in the right position. We can now unfreeze our Inventor model. We just turn those on so we can see what's happening. And there we have it. So we've got our production cell, the machinery, all in place. And we can now say, well, that looks really, really good. As we pan around, we can actually see we've got a problem. We've got a clash between the crane and the ducting above it. And now, because we're Inventor, we can drive our constraints. So it may be that there may be another problem. So what we need to do is activate the crane and actually see if it hits anything else. So just by using the driven constraints in Inventor, we can activate the crane, and then we can see if it clashes anywhere else in our Revit model. That looks pretty good. It's only that one area or that one piece of ducting that's causing us the problem. So what can we do about that? Normally, this would be where you'd have to send an email, a screen print to the person that's in the Revit model or the architectural model and say, I need this change. Well, what we can do is actually send our Inventor model to Revit so we can actually do the change live in the Revit model. So what we can do is simplify, because obviously we don't need every nut, bolt, screw and washer that is in our Inventor model. We want a simplified version that gives us just the size, the shape of the components. Just a couple of seconds. And here we can choose at the bottom here, that's actually going to export directly to the Revit file format. So we're not exporting a step file or a dumb solid, as they call it, to go across. We're actually using the Inventor model, which also gives us a link. So anything we now change in Revit to cure this problem will then also update in Inventor. So again, we've got that bi-directional link between the two CAD packages. So back in Revit, and all we're going to say is we want to insert our linked file now. If you have any questions, by the way, while I'm going through this, just shout out. And there we have our Inventor model in the Revit model. So we can make the change now very quickly. We're just going to come to our 2D layout. I'll tile the view so you can see what's happening. So in real time here and live, we're going to go to the right-hand window. We're going to find our assembly that we've just placed in from Inventor. And if we select it, you'll see it highlights on the left-hand side. So we know we've got the correct assembly. We can then see the piece of ducting that's causing the problem. So all we have to do is activate it. You can see it highlighted now on the left-hand side as well in the 3D model. And then we're just going to change the dimension and we'll push that across by a couple of meters, make that 3000 millimeters, 3 meters on there. And we can now see we've cured the problem, we've moved the ducting, and it's updated everything in Revit. If we then go back to Inventor, we'll see, once that's saved, then we can come back into Inventor. We'll see a little lightning strike at the top of the screen, which says your model is out of date. Automatically, it's seen that we've made changes. So we just click on the lightning strike. It's going to update the model with the latest version that we've just changed in Revit, and then update the Inventor file. So we can see we've got a complete round trip. And again, just thinking how much time that would take if we hadn't done that, and we were emailing files off to people and marked up drawings. It's going to take a lot of time and a lot of effort. So you can see, hopefully, how that works a little bit better. Oops. Next thing, again, time-consuming things. If you've got an assembly and you may be looking for information from a client or a supplier, you would be sending out either marked up drawings, emailing them, or PDF files. And if you're really brave, you'd actually be sending them your CAD data, which is obviously a risk because then they can modify things without, and your CAD data, your intellectual property could be changed. So what we can now do is use the shared views function. This can be done in Inventor and in the Vault system. And it allows us to push out a file, a 3D model, drawing, whatever it may be, into the cloud, and allows people to measure, mark up all of those components without any risk of actually losing the data, because you're giving permission to whatever level they're allowed to interact with that model. You also don't have to have, or the person you're sending the files to doesn't have to have the CAD system. This is all done by an internet web browser, so it could be on a computer, it could be on an iPad, their local phone. As long as they've got a web browser and an internet connection, they can make changes to the markup that you've sent them. So you could have one of your engineers on site, customer site, and the customer's come up with a question about the drawings or the model or the size of it. You can send that file to them. They can see it real time on their phone, 3D model, measure it, mark up, section views, whatever they want to do. Saves massive amount of time. And just to show you that, we've got an assembly on here, and I'm just going to go to my collaboration in Inventor. And again, you can do this in the Vault if you wanted to. But we're going to create a shared view. All we have to do is say we want to create a new shared view. We can give it a name, and we can choose whether we hide component names and also the properties of those components. So it's up to you, the level of information you give to the person that you're sending this to. I'm just going to say everything, and I'm going to copy the link it's produced, and I'm going to email that across in a second. But just so you can see what's happening in the background, we can go for a live view. So it's going to fire up my Internet Explorer, load up the file, and here we can now interact with it. So we can zoom, pan, we can spin it around, we can look at pre-saved views if we had them. I've only got the standard view. But also in our model browser, because we allowed this, we can actually look at individual parts. We can either select it and zoom in. So it's going to highlight the part, ghost out the other parts. So we can pan and zoom around all of those components and find a particular parts. And once we've done that, we can go back to our original model if we want, and we actually turn the visibility off of other components. So we might want to see what's inside the model. We can simply select it, turn off the visibility. But nothing we're doing here can affect your CAD model. So this is purely for visual reference. So it makes the files very, very safe to work with. Once we've done that, we can then send that to the person that's interested. Once we finish with our views, I do get a bit carried away with these views. It's actually quite good fun messing about with it, but we can do section views, as I said. We'll just show an example of that. We can explode the assembly. And we just do a section. When you're creating your section view, you can drag real time, same as you would do in Inventor. Not only can we drag it out, we can spin in the cutting plane around, and again, get the exact section view that we want. Once we're happy with that, just going to close that down. Now I'm going to generate an email. I'm going to send it to myself. So just put my name in there. And then we're going to just paste the link that was generated for us in Inventor. And we're just going to ask the person that we're sending this to take a look at this, just to make sure the dimensions are correct. Paste the link in, hit send, the email gets sent. Once I get notification come through, I can then open the email that's just been sent to me. It's got the link there. Click on the link and it opens up the web browser. Now, again, as I say, this doesn't have to be on your PC. It could be on your iPhone, your iPad, any other tablet that you're working with, as long as you've got an internet connection. So now we've got that, we can come in here. We're going to just make a little markup so we can see what needs to be looked at. And we're going to create a section view. And then we're going to put some annotation in here as well via our markup. I'm just going to drag an area around the area of concern. We're going to add a little arrow in here, and then we're just going to put some text in just to say we want to perhaps look at the dimensions or the tolerance build up in this assembly. We've got a spacer in there. We want to make sure that that bearing doesn't push against the spacer. The shaft's got enough room to have a bit of float in there, and it's also going to be done at an affordable price, because obviously if we go to things like dimensioning, we can actually put it down at the very, very high tolerances, which would cost us an absolute fortune to get machined. So we need to get that balance in there. Once I've created my copy there on my markup, when I come back into Inventor, just do a refresh, and we can see that we've now got a comment that has been added to our original markup. So just to refresh to make sure we've got the latest one, if we now click on there, the markup we just created can be viewed. So I've now got the information back from the client, the customer, the engineer, whoever it may be that I've sent that information to. And I can see that they've said, okay, we've got a problem with this area. Can you just check on the dimensions and give instructions? So moving forward in time, we say, okay, we've had a look at this. Well, I'm quite happy with it. We can simply say that our comment is resolved. It takes it away from live comments, but also keeps it as a reminder. So you've got a history for up to 30 days of what's actually changed. The information has gone backwards and forwards between the two people that are doing this. Seem useful? Yeah. So any questions, or if you're getting bored, just tell me. Yeah. Okay. So moving on then, the expanded capabilities. So inventor tolerance analysis, the thing we were just talking about with our previous video we just looked at, factory design utilities, Nastran, Inventor Cam, and Inventor Nesting. Does anybody use any of these at the moment? Yep, you do. Which one?
I went for nesting. Yeah, we have used it for nesting.
Yeah,
we have a possibility.
Okay, that's good. So first thing then is on the extended capabilities. Dimensions. So tolerancing on dimensions on the model. It's very, very easy to say, yeah, I've got a tolerance of 0.00000001, and it's always going to come out absolutely perfect. But the cost to actually produce that tight tolerance is going to be astronomical. So what we need to do is have a piece of software that can work out where our tolerances are. We've got tolerance build up across the shaft with the bearings, etc. And we want to say, okay, well, to get something that's actually reasonable and affordable, I need to have an intelligent result here so I can actually see what's happening. So what we can do is use our tolerance analysis. So we've got our same component, and as in our previous markup, we just saw someone's worried about the dimensions. So once we go into tolerance analysis, we can create what is called a stack up. And the first thing it's going to ask us is, well, where's the critical dimension that you want to talk about or you want to check? And what we're doing is checking the gap between the spacer and the casing and the bearing in this instance. By selecting that, it will now look at all the constraints that are along that shaft and that component, and it will automatically find all of the constraints that could affect the dimension or the placement of that component. So that gives us our set, as it were. We can then come across into the tolerance analysis area, and we actually see what the tolerances are going to be. So we've got our worst case scenario at the bottom. I'm going to actually set a target here. So I want it to be plus or minus, and we just add 0.25 into our dialog there. Just let that happen. Now that's going to tell me what's the chances, worst case scenario, of none of these components fitting together. Now we can actually find the parts that are causing the problem. So straight away we can see gear housing and the gear 000 IAM are causing the biggest problem. So they've probably got the tighter tolerance on there that can't be achieved, or it could be too loose even. So what we can do is modify that tolerance, and we're going to get instant feedback to actually see what effect that's now had. And we can see it's now leveled things out a little bit, but if we go back to our results, we can still see worst case scenario, there's going to be a lot of parts that don't fit together. The thing to think about though is that is based on worst case scenario. So that's every component either coming in at maximum tolerance or minimum tolerance. What we can now do is go to statistical analysis, and we can say, well, how likely is that to happen? And when we see the chart here, we can see, well, actually, it's going to be a very rare occurrence that all of those components come in at either top level or bottom level of your analysis. So we can make an educated decision on whether we're going to go with that tolerance, because the chances of actually causing a problem are going to be very, very slim. We can then output a report that gives us all of the information and why we made this decision. We could forward this to the supplier, and then you've effectively solved the problem very, very quickly. Obviously, that's a very top level guide through it. There's an awful lot more you can do in there, and if you wanted to see more, obviously give me a shout afterwards and we can go into a bit more depth.
One question. Is it possible to connect it with the cost analysis? Because all these tolerances affect the cost, and some of them,
yeah,
like you showed this diagram at the beginning.
Yeah.
Is it possible to use it?
There would be a way if you exported it into an Excel spreadsheet, so you can put in rules in your spreadsheet that could update from the information that's coming from there. So yeah, you could do that. I can show you afterwards. We'll do a little walkthrough.
And second question, this tolerance analysis, it means that all these 3D dimensions should be, let's say, dimensions should be defined in 3D. Yeah.
Yeah, what you can do, you can obviously use the dimensions that you already in your model, your parametric dimensions, but you can use 3D annotation now as well. So you've got your 3D dimensions, so you can see on there, I've got the one dimension, but if you're using 3D annotations, that will then update dynamically with the changes that you've made to the tolerance analysis, which will then also update in your drawings as well. via the 3D dimensions. So yeah, I'd say I can show you more of that in detail afterwards. So while we're on analysis, we got factory design, which again, very, very powerful packages, and it works between AutoCAD and Inventor. So we can do a complete factory layout, and we can then do analysis on the flow of product, where we store the product to go onto the production line. And also we can use it for checking for clash between components. And again, we're dealing with the factory layout that we may generate in AutoCAD, brought into Inventor. Inventor brings in the machinery, where the pallet truck goes, all that sort of thing. And we can check that we've actually got the space to do that and to work with. Another one here is in simulation. I'm glad you were saying about thinking about using Nastran. So we're going to cover that now. But most people know that in Inventor, it's always had, well, for a long time, it's had simulation in there. So we can do motion analysis and stress analysis. And it's very sort of basic things, standard stress, buckling, that sort of thing. What happens normally when we want to go the stage further? So we are going to do an analysis in a minute, and it goes back to my days from my original Robot Wars robot that I designed. And the weapon on the robot had a big axe arm that we used to fire via a CO2 bottle, which we apparently are not supposed to do it, but we actually used to heat the bottle up a little bit just to make it go a little bit harder. But we can do stress analysis on that, which means if it actuates once, is the axe going to break? And we can come through with the Inventor standard analysis and say, well, no, it's not going to break. But then we think, okay, what happens if I want to be in a battle that's going to last several hours? I'm going to make hundreds and hundreds of activations of my axe. Is it going to survive? How many times can I use that axe before it breaks? That's normally where you would have to say, okay, I've done my analysis in Inventor. I'm going to export all of those files. I'm going to then update them into another CAD package. I'm going to redo all the motion loads, the constraints, etc. And again, time consuming. What we can do though now in Inventor with the Nastran in CAD built in is we'll do our standard motion analysis in Inventor. So I've saved a bit of time. I've set up most of the things here, but I've added a force on the pneumatic ram that's going to push the components forward and activate my axe. The axe then flies over, and it's got a contact set between the end of the axe and the floor that we can see raised, which would effectively be a simulation of another robot it's hitting. Once it hits the deck, we can stop the motion, because we don't need any more motion at that particular point. And then we're going to go to our output graph, and we can see the moment of impact on that analysis, on that axe. So all we can do is search for the maximum force that was implied to the end of that axe. And then we're going to export all of those settings, all those forces into the 3D model, which is the axe arm. Once we've done that, and again, we're still just in normal Inventor analysis here, we're going to go to our standard Inventor analysis. Take a little time to catch up. So into stress analysis, we're going to create a new study. And because it understands the simulation we've just done and we exported the files, we've got a button we can press and just say, bring through all of the motion loads from the simulation analysis. So now it's just not a case of us guessing where the forces are going to be. These are the forces that were generated from a motion simulation. Once we've gone through that, we can add materials, which we've done in the background. I'm just going to take off the pointers. We can mesh the entire model, and then we're going to do our simulation. Just take a couple of seconds. And once we get the results, we can now see very little red, keeping it simple, on the model. So, yep, that's going to survive one hit. So this is the point where we say, okay, how many hits can I get out of this? And this is where we would normally be exporting the files to another package. What we can do now, though, is go to Nastran in CAD built into Inventor. And because we've already done all of the analysis on here, we can bring through all of that data into Nastran, so we haven't got to recreate all of that information. Just wait for this to update. So now, into Nastran, we'll see the information down the left-hand side that it's going to bring through that's already embedded in the model. All we need to do now is make a few changes to what we actually want this to actually do for us. So we're going to create a simulation. Takes a little while to catch up here. And here we're going to define the material it's going to be made of. And then we want to understand what's happening with that material. So we're going to go from our static analysis, which is the default. And now we're going to tell it that we want to do our fatigue analysis on that component. So we're still making very little changes to what's happening in the background here. With all of the main criteria, the forces, etc., have been added via the stress we've already done. We can then look at the fatigue of the material, and we can tell it what we actually want to do here. Once that's done, this table is basically telling Nastran that we want to have 3 stages: 0, halfway through, and complete. And it's going to be fully back, fully down, fully back. So it's going to do a cycle, effectively, of the axle moving in its range of motion. Once we've done that, we can then run the analysis, tell it which table we're using. So it's table 1, which is the complete forward and back cycle. We'll run that analysis. And what it's going to do now is simulate how many times they can go forward and back. And it's going to show us at the bottom here of how many results, or when it's going to be fatigued. So how many times we can hit that axe before it breaks. Now, to me, that looks like that's going to break pretty quickly after we've done several layers, even though it's only going to be about 4,000. But what we can do now, and this is the beauty of the package being built into Inventor, is we can come back to our 3D model. So we're just going to come out of Nastran. We're going to go to our parameters. And again, this is something we could have done via iLogic if we wanted to, just have a slider. But I'm going to say, I'm going to change the pocket depth to 10 millimeters from 20 millimeters. So the middle web is going to be double the thickness. And I can then just drop back into Nastran, do a quick refresh so it understands the changes. So we're just going to remesh the model and then rerun the analysis. So there's the mesh. Takes a few seconds and then rerun. And now we'll see a dramatic difference from our first test to our second test. Once we've gone through this, you can see the chances are we could run this, we could do 1 million hits for this and it's not going to break. So we actually could be in the stage where we're stopping ourselves from over-engineering now. We could bring that back. And so I'm not going to do more than 10,000 hits for this axe in this competition. So as long as it lasts that long, that's all I need. So you can see really, really time saving. Again, that is just scratching the surface of what Nastran can do, but it gives you an idea of how it works in Inventor with the products you've already got in there. I'm doing for time. Other areas you got is in the CAM side of things. You've got multi-axis operations, active clearing, turn-in milling. Pretty standard for all of the tooling environments there. I think Rickard is going to do quite a lot of information or talking about the capabilities of CAM in Fusion later on. But again, you've got exactly the same information here, the same benefits, because everything's built into the program. Once you've set up your tool paths, etc., you may change the model, make a slight change to a parameter. This is then going to update and refresh and show you where you've got problems if you have any. So again, massive time savers. Nesting. So again, you could probably tell me about this as well. So very, very useful. Do you find it useful when you've used it so far?
Yeah, well, how you use it itself.
Yes. And again, it's one of those things when you're dealing with the sheet metal components. Everyone models them, great, okay, but at some point we do need to cut these out from a sheet of steel or plastic or whatever it may be. So we want to make the most efficient way of doing this. So we can actually put the parts in and say this is going to be the most efficient use of that material. That can then be generated to the cutting paths in the CAM system, and you export the whole package directly to your CNC or whatever machine laser cutter that you're working with. Connected applications. So as we've said before, Inventor works seamlessly with AutoCAD, Navisworks Manage, 3D Max, Recap Pro, and Vault Basic. Also, it's Vault Professional as well. You can use it with. But to go through some of those are the interesting areas. So AutoCAD and Inventor, again, this is a time-saving thing. So we may have a lot of drawings that we've done in AutoCAD. We move across to Inventor. What happens to all that data? Have you got to recreate that from scratch? Well, no, you haven't. What you can do is bring through the AutoCAD DWG into Inventor and use that to create your 3D model. And again, working on this relationship between two packages, if you then make a change to the AutoCAD drawing, because we've got a link in Inventor to that drawing, it will update your 3D model automatically if you want it to. And again, you have a choice here where the lightning strike comes up, says this has changed. You can actually say, well, actually, I know that's changed. I don't want my model to change, and we can leave it as it is, or we can hit the update button and it will remodel 3D Solid for us automatically. Moving on to Navisworks. This is a great piece of software. But basically, if you're doing your factory layout, as we showed in the beginning here when doing the 3D between architectural and Inventor, but also if you're doing the AutoCAD to Inventor factory design layout, we can then put this into Navisworks, which allows us to do things like walking around, check everything's okay, clash detection for our components, and also we can work out how long it's going to take to build stages of build that we want for the 3D model. And just to show you that, here we have Navisworks, get the two mixed up. And from our 3D model, again, doesn't matter if it's come from Revit, from Inventor, or from AutoCAD factory design, we can walk around, but more importantly, we can select areas where we want to check if we've got any clash between the components. So simply by doing this, we can select our area and it's now going to show us the areas that have a problem. So we see again, our ducting is infringing on our area that we don't want anything inside. So we can come straight back into our Inventor, have a look at the area that's going to be a problem. Again, we're going to do a shorter version of what we did earlier, but we're going to export this now into Revit, because the Revit model is the part that's causing the problem. It's not the Inventor model that we need to change. So exactly as we did before, we're going to export that out, take it into Revit, use Revit to make the changes. I'll skip through this bit quite quickly, because then we'll go back in and show you what's happened in the final product. So back in Revit, we brought our model through. We're going to do a refresh just to make sure we got the latest version in there. And as we did before, we're going to find the parts that are causing our problem, and we're going to move them in the Revit model and then update the Inventor model after that. So it could be a case of changing dimensions, or we may want to move a component, or we might want to revolve it, whatever it may be that causes the result to be what we want. We're just going to drag that across, move it from our production cell, and move the other components completely out of the way. Once we've done that, okay, same as before, we're going to save it. We're then going to do the refresh. We've got the lightning strike in Inventor, going to update our model. Once it's updated, we can then just come back in the other direction. Let's make this update. So there we can see we've actually made the change, so we can see the effect in our 3D model. Come back into Navisworks, we can refresh the clash analysis or detection that we did earlier, and we'll now see that we've cured the problem that we had initially. Just a little long. And there we see. So the clash is gone. It's going to now just give us other information of any other clashes that we got, so we can do the same procedure to go through that as well. Another area is in electrical. So we've got AutoCAD electrical, which we can use for electrical design, schematics, etc. We can then bring that into Inventor. We can do 3D models of that. We can do cable routing. We can do cable and harness, and nail board drawings and schematics directly from Inventor. But again, we've got that link with the original AutoCAD electrical functionality. So any changes that are made in that will then push forward through into Inventor. Getting towards the end now, but bringing a lot of these things together, what we've got is a laser scanner now inside a building, which can create a point cloud, and we can then bring that through again using ReCap Pro now. We can measure, mark up, bring it into the 3D CAD model. So the factory layout that we've done, we can actually bring that point cloud in, and then we can actually do clash detection from the physical properties of the building that we've used in the scan with the machinery and the ducting, etc., that we're putting in from the model. And obviously we can then affect our factory layout. If we've got any problems, we may need to move something. We've actually got a concrete post that we didn't realize was in the building, but now the 3D point cloud from the laser scan has brought that information through, and we can now do a full test. Just as a side note, when it comes to ReCap Pro, we see here a laser scanner has been used to create the 3D model in the point cloud. But you can actually, and I've done this myself, I'm a qualified drone pilot, and a friend of mine's got a barn that he was wanting to convert into a house, and he needed to put a lot of steelwork in. And in the space of about 3 hours, I put my drone up, took about 300 pictures on a 360-degree spin around the building, put those pictures into ReCap Pro, and it used those pictures to create a 3D point cloud, and we used advanced steel to do all the steel work inside of his barn. And that's by using a 300-pound drone. Obviously, it's great for external things. If you're doing the hull of a ship, then you're not going to be able to do it with a drone. You need a laser scanner, but the options are there. And again, ease of use is fantastic. And finally, once you've done all this design throughout all of the packages, you might want to do some marketing material. You might want to put this forward as a quote, maybe changes that you need to show a local committee of how things are going to go, how it's going to fit together, how production is going to work, how much quicker it's going to be, and how much better. We can use 3D Studio Max directly from all of the CAD models that we've used and created in the background and create our own marketing material. Lastly, and I'm not going to do very much on here because Rickard is going to carry on with this in a second, is Inventor and Fusion 360. One of the key ones I've picked out here, and again, Rickard will do an awful lot more information here, is generative design. So we can seamlessly create a 3D model in Inventor, push that across to Fusion 360, and then use the generative design to actually give us a cost saving or a stronger version of the model that we've created. And again, he's going to do much more detail on there, I'd imagine. But we've now got a tab in Inventor, so you can dynamically send across structural components into Fusion 360. So you can do additive, subtractive, and modeling design directly from the two packages, and they talk to each other quite seamlessly. That completes my presentation. Hopefully you found that useful. I'm here all day if you need more questions later on, but thank you very much.
Okay, thank you, Paul. So do we please have any questions, additional ones, now after your magnificent presentation? I mean, I was thinking perhaps it would be easier next time for you to do a presentation on what Autodesk can do instead of what it can do. At least to me, it seems there are so many possibilities there.
Yeah.
Okay, but please, in free form, please comment, ask questions, add something, speak from your experience, if you have.
Just one question.
Yes, Meelis, please.
We have so many different modules in software, right? What is the logic of these modules? Is it all kind of from the same family or the same logic? Or sometimes it's like even in Microsoft Office, if you're using Word or PowerPoint, some logic is a little different. If you have very many different licenses, different modules, then it's
Okay, yeah.
really one person capable of managing this, or is it just you have many modules, but different people will work with these?
Yeah, I mean, basically, yeah. So with the manufacturing suite, you've got a suite of products. So it's exactly the same as Office, you know, with Excel, PowerPoint, Word, etc. And it does give you, makes things easier when it comes to the licensing of a user, I would say, because if you imagine we've got 5 people, one person does electronics, and one person does stress analysis, whatever it may be. Previously, you'd have to buy each individual piece of software on a separate license for each one. But what we can do is say we've got manufacturing license effectively set up for these 5 people. And same as with Office, you can choose to not install Excel or Word. You only want PowerPoint. and you don't have to keep downloading a different package each time. You've got a suite of products that's complete. And yes, there are going to be packages in there that you probably never use, but then there may be that one time that you need to use it, and it's there. So yeah, I think the analysis with Microsoft Office is a good one. There are going to be parts that you don't use, but then there will be parts that are going to be a lifesaver later on.
For the user interface, is it similar or
yeah,
different?
I would say most of them are similar. Yes, there are obviously packages that have been acquired by Autodesk that are slightly different, but you will notice as the updates come along, as in 2023, we had a completely new front end on Inventor. So we had the dark screen and all that sort of thing. So you'll see them gradually start to filter together to give a common look, I think. That's my opinion. It's not definite, but yeah, that would.
What about the scripting languages that are used? Is it a lot of different or just?
I'll be honest, I don't know. The scripting bit is not me, but I can get the answer for you from later on.
Thank you.
Okay.
Just for the sake of discussion, there was mentioned the licensing. How is the licensing working for this package, manufacturing package? Is it that you have to buy it? Is it on your computer or web page or web-based?
That's a good question. Okay. There's been a few changes, but you'll have a single license, single user logon effectively. So that and your administrator will be able to set which licenses are allocated to your login. So yeah, you effectively only have one license to worry about.
I have a question. Over here showed us, but very impressed, work very smoothly. But I guess when one starts doing it by himself, then there are some errors and things don't work exactly like it should. So what would you recommend, or how have you learned? What's the best source of getting them?
Yeah, I would say training is a key thing. Now, levels of training, you don't have to do everything at once, I think is a key thing there. So I would find the areas that you're confident with, find bits that, or new areas that you're walking in. So you're going into Nastran. Yes, you could spend a couple of weeks clicking all the buttons and seeing what things do. But if you've done a 3-day training course, obviously with these guys, you're going to be far better set, because there's always going to be a time, there's so much functionality there. If you don't have that basic training, you're never going to get to the more complex things, because you just can't understand this bit and things don't work, or you get, like you say, the errors are coming up. So I would absolutely say training is the way forward and have focused training on each of the components that you actually need. So the first thing you need to do is, okay, this is my requirement, this is my pain area. So I need to do more analysis because I've got problems with fatigue, snapping, parts breaking in the field. So Nastran is the thing you want to learn on. So I would say I need to book a 3-day, 5-day, whatever it may be, training course on that piece of software and just focus on that. I've seen many times people would try to do a training session themselves where they send one person and they then train everybody when they get back to the business, as it were. Again, that's probably not a good idea. You need to find the key people that need to use that software, get them properly trained. And then there's always the help side of things later on. If you've done some training, you get to a particular area where you've got a particular problem, you can use the Autodesk support system via the guys here, and eventually that'll come probably directly to myself. I can then contact you direct and actually walk you through any of the problems that you got. But yeah, training, I'm afraid. Sorry to repeat myself, but definitely.
Another question about this training part. Are there these tutorials available on each module?
Yeah, every
Are included with the license, or is it separate?
No, there are
different policies.
Yeah, with all of the functions and features in near enough all the software I've shown you there. If you click on a button that's going to fire up your analysis, if you hover over it, you'll see a little window appears that says help. And you can click on there, and there's built-in videos and training scripts within the software that will take you through the basics. But then you can also use the Autodesk knowledge area online. And again, there's a great source of information there that will give you basic information how the features and functions work. So yeah, there is some built-in help files with all that information as well. The other thing you'll find is when a new release comes along, so when we go to 2024 next year, you'll see on the page when you first open Inventor, for example, there'll be a big banner that says what's new, and you can click on there and it'll have animations and presentations that take you through what is new in the version that you've just purchased. Okay.
Okay, thank you, Paul. Anyway, Paul will be here until the end of the day, so you just take your chance and grab him and ask questions. With this, I think we will move forward. Rikard, are you with us?
Yes, I'm here. Absolutely.
Yes. I would suggest if you perhaps can give us 2 or 3 minutes so everyone here can go and fresh up with coffee and water. What do you think? For 3 minutes problem. And then you can take it over. Ühesõnaga, ma pakun välja, et kasutame ära võimaluse minna võtta kohvi või vett praegu 2-3 minutit ja siis jätkame teise presentatsiooniga. So, next presentation, also in English and also from a person from Future Group, but this time from Sweden. Rikard, are you with us?
Yes, I'm here. Absolutely.
Yes. So I would like to stop my screen share and please take it over and you can start.
Thank you. So let me share my screen. So hopefully you can see it. Yes, you can.
Yes, it's excellent. Can you please also put it on the presentation mode, or is it already? It is already.
It should be, yes.
Let me see. Okay, now it's much better. Yes, we have attendees. Everybody is here. So yes, please, you can start.
Thank you. Thank you very much. So my name is Rikard Levenstad. I work as a technical sales specialist, as Paul is, and I'm based in Stockholm. Today, sunny Stockholm and a bit cold. I'm working with Fusion 360 a lot. I do a lot of CAM trainings for end users. I do a lot of customization of post-processor for end user for Fusion 360, Inventor CAM, and also for PowerMill. So I've been working with PowerMill formerly from Delcam for about 23 years. And it was acquired by Autodesk 8 years ago, and then I started work for Future Group. So a little bit about me. When I'm not working, and if you want to speak about model airplanes, radio-controlled model airplanes, well, then I'm up to discussion for sure. And I spend a lot of time in Fusion 360 designing my model airplanes. And then also I produce molds in aluminium or in plastic materials to cast the model airplanes in carbon fiber, glass fiber, and epoxy. So that shows you that you can do a lot of design work in Fusion 360 as well. Also, I spend a lot of time designing my own CNC machines. So the machine you can see on the screen, it is designed in Fusion 360. The simulation using Nastran solver inside Fusion 360 is used to make it strong enough. And also I use the sheet metal for the enclosure of the machine. And then I built the machine as well. So that is a nice hobby. It also shows you can use Fusion 360 to a lot of stuff. So today, I will talk a lot of CAM solutions, but also some other stuff in Fusion. But let me start to give you an overview of all the different CAM solutions that's included in Autodesk portfolio. So as I mentioned, I have been working with PowerMill that comes from Delcam from UK in the past. That is a really powerful 5-axis milling software, nothing else. No CAD, no turning, just milling machines and really advanced stuff. We also have Inventor CAM included in the product design and manufacturing collection. That is a module called HSM for milling and turning inside Inventor. Also in the product design collection, Fusion 360 is included. Also here we use the HSM module. So it is about the same functionality in Inventor as in Fusion 360 at the base. But then on top of that, there is additional functionality on the CAM side in Fusion 360. So a lot of customers working with Inventor for the design work, they use Fusion 360 for the on the manufacturing side. There's something called Autodesk HSM, also included in the Fusion license, and that is a plug-in into SolidWorks, the HSM CAM module inside SolidWorks. We also have a feature CAM and part maker, also from PowerMill in the past. That is software, maybe the most automatic CAM software at the moment, and they are very good on turning. So let me give you a quick overview of PowerMill, and I will explain why I'm doing that in a few minutes. So PowerMill is advanced 5-axis milling and often used of companies doing injection molding. When you ask for high quality machine parts or complicated parts because of you need a short milling tool and it's a narrow area and you need to modify the tool angle of the machine, and that could be done very flexible in PowerMill. Also, the calculation speed in PowerMill is really fast. So if you have large models in a large milling machine, then PowerMill could be a solution. But if we switch over and talk about Fusion 360, the software Fusion 360, we can see that we now have the DMK kernel inside Fusion 360. And that means the calculation from PowerMill, everything, all the calculation taken part in PowerMill, that is also included in the calculation in Fusion 360 on the CAM side. So it's up to the developers at Autodesk what kind of feature they would like to turn on inside Fusion 360. But it means we gain calculation speed, and for 5-axis machining, we have a lot of functionality coming into Fusion 360 from PowerMill. The same thing happens with feature CAM. A lot of stuff from feature CAM also comes into Fusion 360. And from NetFab, that is a software for 3D printing or additive manufacturing. A lot of stuff from NetFab is also coming into Fusion 360. And the same for MoldFlow, that is an advanced software for simulation used for simulate injection molding. And stuff from MoldFlow is also coming into Fusion 360. So we'll see that Fusion 360 will be like we pick up a lot of advanced features from different softwares and make it a little bit easier to use, easier to understand inside Fusion 360. I show this safe harbor statement, normally used from Autodesk, but it means what I will show you today, it's partly preview functionality, and you should not make any investment decision based on my presentation. You can check if things is coming in the future or not, but because it's preview functionality, it's not 100% sure it will show up exactly the way I showed in the software when it's released. So Fusion 360, it's a cloud-based software, if you read on the internet, but the software is installed on your client, but it is cloud connected. All data I create in Fusion 360, it will be pushed up to the cloud Fusion team. So it's possible to share the data in similar way that Paul just showed you that you can do with Inventor. And we can also cooperate with the data created in Inventor and pushed into Fusion team or the cloud. And then we continue to work with it in Fusion 360. So I can see a trend that a lot of customers work with Inventor, and they also start to cooperate with Fusion 360 through the cloud. Fusion 360 is device independent, so you can work on a Mac or a PC, or you can work on a tablet, or you can read the data on a mobile phone because it's stored in the cloud. And yeah, it's easy to collaborate. Just like Paul showed you from Inventor, we can do similar things from Fusion 360. And as I said, it's no problem to work with Inventor, but also from other software, we can load data. If you're working with SolidWorks, as an example, you can load the SolidWorks native file into the cloud, and we can open that in Fusion 360. If you update the SolidWorks file, it will be updated in Fusion as well. And that is the AnyCAD functionality, works similar as with Inventor. Good to know. So, cloud computing, that is something that we talk a lot of today. All the simulation in Fusion 360 with the Nestra solver is pushed up to the cloud since a couple of months. So no calculation in Fusion is done locally for simulation. So it means if I do calculation, I can set up all the parameters. And when I hit the solve button, it will be computed in the cloud, and I can continue to work with something else. So it will offload my computer. So that is a good benefit of cloud computing. Also, I don't need as heavy computer, so to say. So because of the calculation is made in the cloud. So maybe in the future, we will work on much lighter computers because of this. We also have the generative design. That is a different way to design parts. You put all the parameters into the system, and then the system will generate the CAD data for you, both for structural components, but also for fluid optimization. But that is also generated in the cloud. So you put you create all the parameters locally in your computer, and then you push it to the cloud, and the computers in the cloud will calculate everything for you. There is something also under preview at the moment, but it's called automated modeling. It is similar to generative design, but without the simulation. So it could automatically generate a CAD data between different phases, the same way generative design could. But this is artificial intelligence put into Fusion 360. There is a lot of new thinking with Fusion 360 with artificial intelligence and cloud computing. This is a picture I like because it shows the transparency of development in Fusion 360. This is the roadmap for 2D drawings. So there's a lot of stuff going on with 2D drawings. It's not so important all the features we have here, but I like its transparent development. And also there's a lot of stuff going on also 2D drawings. So going to Autodesk University in New Orleans or online in this fall, you could hear about a top secret project at Autodesk named Bluebird. But Autodesk did tell that they are working on a project creating 2D drawings fully automatic. So the intention is to be able to upload your components into the cloud, and then you could download an automatic created 2D drawing. And it should be possible to learn the system, how you would like the flavor of your 2D drawings with artificial intelligence. Also at Autodesk University, there was a secret project, announcement of the secret project for CAM calculation, also taking part up in the cloud. So maybe in the future, I don't know what time schedule it will be, but there are tests going on at Autodesk, uploading the CAD model into the cloud, and then the calculation of the toolpath will be done automatically with artificial intelligence in the cloud. So that means Fusion 360 is cloud connected, device independent, and cloud collaboration. We hear about that if we look at the internet, but that's not what's about the cloud for Fusion 360. With Fusion 360, the cloud is about auto-generate data for us. So we upload a lot of parameters, and then we can download a CAD file, 2D drawings, or maybe also in the future, a CAM file. So that is really impressive. So I would say the future is here, and it runs on Fusion 360. And Fusion 360, that is the next generation CAD and CAM software, I would like to say. Good. Let's move on to Fusion 360 and some CAD and CAM stuff. We had an update of Fusion in November. We have a normally one update every month of Fusion 360. It's pushed from the cloud, so we don't need to do anything else than restart the software, and it will be automatically updated. So in the November update, Autodesk announced that in March 2023, we will no longer fully support some OS listed below. So it could be good just to notice that it doesn't mean it will stop working directly. It means we don't have the fully support for the OS if something happens with the support with the OS. You can find the information inside Fusion 360 under the question mark and what's new. You will always find the new stuff in Fusion under there. One major thing in the November update is speed, the performance of the software. We're always working to make the software faster, of course. But if you look on extrude, revolve, and other features for large assemblies, where we had some problems with large assemblies, there is a huge difference and a huge performance difference in this release. Also, open the files, close files, or general feeling when you're working with the software, it's much faster today than it was before this November update. And of course, we continue to improve this performance of the software. And maybe here, there's the biggest difference between Inventor and Fusion 360 at the moment. If you're working with large assemblies, Inventor is much more powerful than Fusion 360 at the moment. In the design workspace of Fusion, when you're working with joints in the past, well, then you could create your joint, and then in a different form, you could update the joint limitation, limits of movements and stuff like that. A small update, but it makes life a little bit easier working with assemblies in Fusion. We connected those forms together. So that is a design update. Also, with Fusion 360, there is a lot of extensions. So if you subscribe to Fusion 360 or use Fusion 360 from the product design and manufacturing collection, you will have the basic functionality of Fusion 360, and you can buy a subscription for additional functionality in different areas. So the extension manager now shows you a little bit easier what extension is active on your license. And also you can activate it directly from here, or you do it from your Autodesk account. You can move your extension to different license of Fusion if you like that. So if you have 10 Fusion 360 license and you have one additive built extension as an example, that additive built extension could be moved around to those 10 licenses of Fusion 360. So it's a very flexible way of working with the extensions. Also, we can see that inside Fusion at the moment, we have about 53 preview features. So that's quite a lot of preview functionality. And if you look under your name on the top right corner of the software and look for preferences, you will find a list of all the preview functionality. You can turn it on, and they are divided into 3 different groups. One group is public preview features. That's open for everyone. There's an insider preview features, and that is locked to an insider group, or if you're taking part of the insider program of Fusion 360. And you can apply for the insider program through the software. So if you go to the question mark on the top right corner and the community and insider program, you can apply to get insight for those insider preview features. You can also install a preview version of Fusion 360 if you're in the insider program. And then we also have a group called extension preview feature. That is preview functionality that is in the extension functionality. But at the moment, 53 preview features, you can turn it on, and I will show some of them in a few seconds. And it will show up in the software in the near future. So that's quite a heavy development of Fusion 360. So if I talk about the manufacturing or the CAM in Fusion 360, there was a major update in the November update, and I would like to take the chance to show you a lot of stuff from the manufacturing update. And of course, we have the DMK kernel, the Delcam machining kernel. That's the calculation from Power Mill. That's been in Fusion for a couple of years. But we now turn on more and more functionality from Power Mill inside Fusion 360. Not a copy of the functionality in Power Mill, but we try to keep everything easier to use than it is in Power Mill. And still, it should be really powerful to use for your milling and turning machines, of course. So we will see right now, we have 8 new milling strategies in Fusion. And there is 2 more milling strategies coming in the near future. So 10 more strategies for milling. That is quite impressive, I would say. So there is one flat machining with inclined flat, automatically 3+2 machining. So that's the trend in Fusion, doing things automatically. It will find all the different angles automatically. I will show it in a minute. There's a deburr function to deburr your part, obviously, and that is 3-axis, 4-axis, or simultaneously 5-axis. So that will save a lot of time for programming your part, and it will also give you a part that looks more exclusive, I would say. The steep and shallow strategy included in the machining extension that would have a new option with open pocket. I will show you that as well. Rest machining, that is always a topic for CAM software. And we have a corner strategy copy of the strategy from Power Mill. But under development, we have a new corner rest milling strategy that will show up in Fusion in the near future. There's also something called flow strategy. So we have a preview of the flow version 2. I will show you that, and I will show you the difference between the flow we already have in the system. Rotary pocket, rotary contour, that is 5-axis machining or 4-axis machining. And that is made more or less automatically from the software. Advanced swarf machining, and also there is 5-axis roughing coming up in the future. So it means in the future, you should be able to machine a pocket. If it is undercut, you machine it as you've done today with a 3-axis strategy. but you can turn on a 5-axis functionality, and then the system will automatically machine the undercuts for you. So it's almost like magic, but that's not today, it's in the future. And also we have machine simulations, so we will see inside the software what's going on in the machine. And that is code from a software called Complete that was acquired from Autodesk a year ago. So that's under preview as well. But first of all, if you're working with Fusion 360 and CAM or with Inventor CAM, I would like to show you the tool library in Fusion. So if I switch over to Fusion, and in the different workspaces, I work in the manufacturing workspace right now. And if I look into the tool library, we can see if I go to my own tool library and select the milling tool, and directly down here, we have different presets, different settings for different materials or different cutting conditions. So if I edit this tool and check the cutting data tab, you can see you can add a new preset here, and that will change the spindle speed, rates, and also step down and step over value, the default value. Also, the coolant could be linked to the preset. So that makes life a little bit easier for the tool database. In the past, we had to create a copy of all the tool if we were using aluminium or steel or other materials. But today we use the preset. So that is a great benefit. And also, if you look at the standard libraries included in the installation, you will find like drilling tools and a lot of parameters for different materials. So we can see in this November update, there is a lot of new icons everywhere in Fusion. So if we look on the coolant settings, there is icons for the coolant, or almost everywhere in Fusion, you will find icons instead of only text. It's a small update, but it could help to work faster looking at the icons instead of reading the text when you're doing something. Also in Fusion, there is a new way of selecting the face on a part. That is a good time saver also when you're doing your CAM preparation. So this is a preview, but it is with a green eye. It's a public preview. You can turn it on and it works just perfect. Maybe they will change or add extra functionality here before they release it, but it's very fast. So I will show it on this part. It's an aluminium part, and let's say we will machine it in a Dacron milling machine with a vacuum table and with a paper board on top of the vacuum table. It means it works as a waste board. We can machine halfway through the paper, and that means we can machine all the way around the part without clamp it in a different way. So switching over to Fusion again, I just created a setup before this presentation. That's what I had, a setup with the Z-axis upwards and the X-axis in the right direction. So if I now select the 2D contour strategy from the tool list, I select my milling tool from this tool library, 6mm tool, and I say I would like the cutting data as I named to aluminium normal machining. And then under the geometry, previously I have to click on each and every contour that I would like to machine. Today, with the face contours, I can simply click on the face, and it will automatically select all the contours for me. So that will save a lot of time, of course. So on the set height, maybe 0.3 through the cardboard, and then I will remove my lead in, lead out. I will put on ramp 1 millimeter at a time, and maybe like this. and directly I will see my toolpath like this. So good to note it is those contours of the holes where the tool doesn't fit, it will not try to machine that. In the past, if I selected those contours, well, then I had a toolpath on it anyway. So this is much more intelligent. I can do similar work with drilling. If I select my drilling tool, maybe I just will mark it with a small drill, normal preset. And instead of clicking on the cylinders, the holes I would like to machine, it's possible to say I would like to select the holes from a diameter range. So let's say I will find all the holes from 2 to 10 millimeter in diameter like this. And then I just will pre-drill it with a small drill. And of course, I select the cycle just like normal. And then it's done. So it could be done fairly easy for this part, just cutting the part and then just mark the holes like this. Super fast. Good. So this means I did the machining for this one, and maybe I should create a different part, a part like this, same material. Maybe I would like to use the same tool. Well, a good tip for you could be I simply select those tool paths and copy them, and then simply paste them into a different model. Fusion tells me it's not calculated, so if I just generate those tool paths, it will generate the drilling automatically. The 2D contour, well, I need to say it should be the face, select this face contour right there, okay, and then it will be machined exactly the same way. So that is a quick way to copy and paste your toolpath between different models to get the same result. But doing that, then you can also create your own file where you save all your toolpath. This is a good way of working in Fusion or Inventor Pen. So I have created a setup for my machine with an end mill 6, and here I save different toolpath, different scenarios, and then I can simply copy and just paste it in a different model and machine it from there. Saves a lot of time, and I know exactly what's going to happen in my milling machine. Also, there is an API in Fusion 360 worth to mention. You can create scripts for basic stuff. So it's not like iLogix inside Inventor that Paul showed you an hour ago. So in Fusion, there's Python script that is more or less programming. So you need to be a little bit more skilled than using it in Fusion inside Inventor. But on the other hand, there's a lot of information about it. In Fusion, you can find it right here on Fusion 360 API. And you will find a lot of example codes that you could use. So you don't need to start from scratch. And I created quite some scripts by myself. So if I switch over to utilities, add in, I have a list of my scripts here. So I created a very basic, very easy to do script to post-process the active setup. So this setup is active, and then it will post it with the post-processor I described in this script. So I just say run, and there I have my code. So it makes life a little bit easier for me instead of using the normal post-processing tab here, select the post-processor and select what operation I would like to post. But it depends on how you work, of course. But it's an example of the scripting, what you can do in Fusion. So let's look into the flow strategy. That's also a preview, a public preview. But if I look at a part like this one, 3-axis milling or 5-axis milling on this part, with a flow strategy, it is an excellent strategy to machine a selected phase. So this is the old flow strategy, where we select phase on the model, and then the strategy will machine with a tool and the contact point within this region. This is a strategy that is calculating directly on the surface model. So it means it depends on the U or V direction of the surface. So I can simply click like this. And also I have to decide how many toolpaths, how many step overs I would like on the surface. Okay, that makes it difficult to get the correct step over in millimeter. That's been an issue in the past. Also, it's an issue, the quality of the model or the surfaces are slightly different. Then the toolpath will be cut like this, or it will end like this. So this will give me quite bad surface quality on the machine part. So with a new flow strategy instead, I still select the faces like in the past, but I don't have to decide if I should machine along or across, because I do that where I select the isometric direction of the surface, U or V direction. And then also I say I would like to have a step over in millimeter value instead of number of step overs. And also the calculation, the quality of the toolpath is much better. So it's together instead of break the toolpath like in the past. The quality of the machine part is much better, I would say. There's a strategy called inclined flats. It will be placed in the machine extension in the future, but at the moment, what is under preview, it's free for everyone. And is 3+2 axis toolpath. So when I calculate the toolpath, I will be just tell the system I machine it like normal, but on the multi-axis tab, I can tell the system that we should incline flats, and it will find all the direction automatically, but I can limit the tilting of the machine, in this case to 30 degrees. And that means that the toolpath is, if I simulate this one, on top, it is a 3-axis toolpath because the top surface is absolutely flat. On this inclined plane, well, that is a 3+2 axis milling. So that is done automatically in the same toolpath. And the transition from the straight to this 3+2 axis section, it will be a 5-axis connection. This makes life really easy if you have a machine, a part with flat planes in different angles. In the past, you had to select each and every plane and create a separate toolpath for all the different directions, but now it's done automatically. And also, as you can see, it's possible to exclude areas. In this example, I have excluded 22 surfaces, or I can add even more surfaces I would like to exclude. So maybe I would like to machine them with a different tool. So that's possible. But the time saver for sure, and it makes it more automatic for us. There's also a preview called debar. So that is for debarring the model. So this is placed under the 3D strategies and the debar on the bottom here. What it does is I simply select the model, or I simply don't select anything. But here I exclude those vertical walls. It is also possible for me to say this should be a 5-axis debarring operation, or it should be a 3-axis operation. And I can again limit the tilting of the machine like this. So doing that with a ball nose tool, a short ball nose tool, if I simulate this one, we'll see this is a 3-axis debarring. I'm just cutting the sharp edge with the value I entered in the strategy. But here it will machine it 5-axis, because else it will have given me collision. Now you can see it tells me there's a lot of collision here with the stock, but that's because I didn't rough it. So it looks like this. But else we will get an indication if it's safe or not on the bottom line. So this is only strictly for debarring, but it will save a lot of time for me. For steep and shallow, we have something called open pockets. So again, in Fusion, with the steep and shallow strategy that will calculate both steep and shallow area automatically. It could give me like those closed segments in this flat area. And this could give me bad surface finishing on the part, because the step over is slightly larger in this sharp geometry of the toolpath. So what I do with the new settings inside steep and shallow, a small update, but here I can say it should be open pockets when I'm using the scallop, and that means the toolpath will be open like this. And this is a small difference maybe, but on the surface quality on the part, it's a huge difference. So that's a good example of what's going on in the development in Fusion. And it's possible to use that through the preview functionality. There's a new strategy. It's also a preview. It's called corner rest milling. Okay. If you're working with injection molding tools or other parts where you have rest machining because there's small radius and you would like to move on to a smaller and smaller tool, today you can use the pencil strategy. So you have a pencil right somewhere here. Maybe I'm blind. Pencil, there we are. Pencil strategy. So the pencil strategy will ask you if you would like to do rest machining from a tool. You tell that you've been previously used a 6 mm diameter of the tool, and then the system will find the rest material from this tool and to the tool you're using, a 3 mm in this case. So that's why we only get toolpath in the corners like this. The problem with the pencil strategy is sometimes it gives me a really bad result like this. It's more or less rubbish, I would say. But with a new corner strategy, it will create a much better quality of the toolpath. And this is a toolpath from PowerMill. And we will see, this is a copy of the toolpath from PowerMill, but in the future, we will see a new pencil strategy that is even better than what we have in PowerMill. Also, with the pencil strategy, it is possible to activate something called collision avoidance. So if I'm machining 3-axis, that's what vertical means, and activate collision avoidance, it will automatically avoid collision by tilting the rotor axis for me, fully automatic. So it makes it really easy to calculate the 5-axis toolpath in PowerMill instead of doing it more complicated in some other software. So this corner with collision avoidance, we can see in areas like this it is automatically building the tool for us. 5 axes simultaneously or 3+2 axes, if that's enough. There is some strategies called rotary pockets and rotary contour. That is also in the machining extension. But this is more or less magic, because in PowerMill, that I said, it's a really advanced software, but in Fusion, it's much more easy to use. So if I select the rotary pocket strategy and tell the system that my axis, my rotary axis is along the part, I select the milling tool I would like to use. In the passes, of course, I have to enter the step over and the step down, but else I just hit OK to calculate the toolpath, and it will find all the pockets and everything for me fully automatic and do it 5 axes. So you can see directly here the result. It finds this pocket and all the 3 pockets for this one. So I can do exactly the same in PowerMill, but it requires a lot more work from myself. So this is the way to go with Fusion, automatic CAM, and maybe in the future in the cloud. Same for the rotary contour. It's similar setup, but it will find the contour, but 5 axes for me. So it doesn't need to be a cylinder like this. It could be a conical shape or irregular shape of the model, and it will generate the toolpath anyway. And then we also have collision checking in PowerMill. This is a topic when you're machining 5 axes, of course. So if I look into my strategies or my part, my flat mold like this, and I create a simple toolpath like this. This is just a face cut. Of course, it will collide with, if I position the tool here, you can see it will collide with a fixture, and it will alarm today with the basic functionality of Fusion. It will alarm if we collide with a fixture. But if I simulate this with a machine, because in this setup, I have added the information of the machine. In this case, I selected the Haas milling machine, and I simulate this one with the simulation with machine. It will be possible to see the whole milling machine like this. It will position the machine, how it will be positioned in the real life. I can turn off the base of the machine to make it easier, and if I calculate here, it marked with red, and it tells me that the Z-axis and the Z-axis collides. So this is automatically collision checking with machine parts. So that's the future in Fusion. Today, with this preview, it simulates single toolpath. So where this toolpath ends, right, with the green arrow, and the next toolpath starts right here. The move in the between is taking care of the post-processor. But in the near future, beginning of next year, we will also be able to simulate that movement inside Fusion 360. And we will use the post-processor to do that simulation. So that is really, really advanced stuff. Things we never done in PowerMill, and I've not seen it in other CAM software as well. So this is the next generation thinking of machine simulation. Also, in the November update, of course, we updated a lot of post-processors. You are free to download post-processors from our library on the internet. It is the same post-processor in Fusion 360 as inside Inventor CAM. But if you need help with adjusting post-processors, well, then we're here for you and we can help doing that. Good. That was everything I had time to do in this presentation, and I hope you found it interesting. And if you have more questions about CAM, you're free to ask here or after the meeting, of course. Thank you very much.
Okay, thank you, Rikard. Do we have any questions from the audience, please? Can you please share this screen back to me? I can try to take it away from you.
Yes.
Okay, thanks. Yes, just to check if the microphone is working. Anyway, if nothing else, I myself, I would like to ask some questions, raise some discussion subjects that we have encountered before various times. The first thing, let's say if you had 2 minutes and you had to give an explanation, I mean, this is a scenario we are facing quite often here. What is the difference between Inventor and Fusion in 2 minutes? Is there such a short explanation? I mean, why there are 2 similar products? Very briefly, may please.
Yes. Well, first of all, it is almost the same product because it's the HSM kernel doing the calculation. So if you're doing basic stuff, basic 3-axis or 2.5 milling or basic turning, you can choose working inside Inventor CAM or Fusion 360. It's the same functionality, you get the same result. But if you would like to machine simultaneously 5-axis or more advanced 3+2 axis or more advanced turning, then Fusion 360 is the way to go because of the machining extension and also the additional functionality that is inside Fusion 360. And yeah, and also it could be a price issue, of course. Fusion 360 license is much lower than the product design and manufacturing collection. So you could have a setup that you're doing all your design work inside Inventor, and then the production unit is using Fusion 360, and you use Fusion Team from Inventor and push your designs into the cloud, and then you can do the CAM inside Fusion 360 because of the license is cheaper than the Inventor license. So that could also be a reason.
Yes, Rikard, I was more meaning in a more general direction. Let's put the CAM module aside. In general, let's say, I mean, okay. Let's not speak about specifically CAM here, but in general, in 2 minutes, what would be the difference between the 2 systems?
Yes, so we see a lot of people using Fusion 360 as a construction software. If you are a small company, if you are a startup company because you are price sensitive, and you don't need to put all your data inside Vault because we can't put the data we create in Fusion into Vault. So you're more or less on your own with the data you create. So that could be the reason for working with Fusion. Also, some people say it's if they do concept modeling, it's faster using Fusion 360 than doing the work inside Inventor. I also see a trend that people with Inventor start to use the license of Fusion 360 in the PDMC to do concept modeling because it's faster. You have more freedom doing the modeling in Fusion, partly because it's not a part modeler or assembly modeling file you start. You do everything in the same file format. So it could be a reason of that. Also because you have generative design, you do the calculation of the simulation in the cloud in Fusion, not locally in your computer like you do in Inventor. Maybe you can have a smaller computer because of that. So it depends on what kind of company you are, I would say. If you're working with Inventor today and that is working fine, I don't see a reason to switch over to Fusion 360. But if you're a new company without any license at all, then Fusion 360 could be a good start software.
Okay, thank you for your ideas on this. The next, let's say, kind of discussion or question, what is your personal opinion? Where is the licensing policy of Fusion in general moving? Let's say in the history, we have had the so-called free version for a hobbyist, which is, to my knowledge, which is not there anymore. We have seen hourly rentals of Fusion, and these have all like gone for now, if I'm not mistaken. Right now, we should have only academic and business. Is it so?
No, that's not correct. You can always download a 30 days trial of the software.
Yes, of course, there's the trial.
Of course.
Yeah.
And when that trial has ended, you can tell that you're a hobbyist or you're using it without making any money. So that means you can still get the free license of Fusion 360 if you work at home, no cost at all. It is slightly limited in functionality. You can't do simulation, you can't do generative design, you can't do 5-axis machining with a free version, and it's limited to 10 different models that is active at the same time, but you can switch and change which model that are active. You can also apply for a startup license for free. If you have a turnover for $100,000, I think it is, then it will be free for you. You get a 1-year license for free, and then you can ask for a license for 2nd and 3rd year as well. So it's no change in those licenses.
Okay.
No?
Okay, good. I was misinformed that the hobbyist license is gone.
Yeah.
Okay. So in meanwhile, anyone else would like to contribute to the discussion? Yes, please.
Does Fusion have any frame generator construction type?
No. No, so that is also a difference. The frame generator is not in Fusion. No, it's not.
For the wider public, please can you shortly explain the frame generator is something to do with some kind of constructions made of frames, like tubings and stuff, is it so? Or what is the frame generator?
Yeah, maybe Paul is in the room and can explain it better than I can do.
Yeah, frame generator is basically steel structure work.
Okay, understood. Yes, weldings and in that direction.
Yeah, so
okay. Yes, please.
What's the 2D main difference between the 2D drawing functionality of Fusion and Inventor? Inventor can create quite a detailed 2D drawing from the model. Is that the same in Fusion, or is there a difference in detail that you're actually able to put into 2D construction drawing that you would send to a workshop to a person rather than file to a machine?
You can do the same in Inventor and Fusion 360, I would say, with the construction work, absolutely. And also with the 2D drawings, it's linked together in the same way. If you modify the solid model, it will update your 2D drawing. So that's not a big difference. The big difference between Inventor and Fusion is the possibilities or the speed. If you're working with a design with thousands of components, that works just fine inside Inventor, but in Fusion 360, it will slow down the system. That's the problem area in Fusion at the moment, but we're working on it and it will be faster in the future, but there is a speed issue. And loading that Paul showed you earlier, loading the Revit file and scan data into Inventor, that works just perfect. Doing the same thing in Fusion, I think that will, yeah, it will be really difficult to do that kind of work in Fusion.
Okay, thanks. Speaking about the licensing and file management, a question popped to my mind, something we have seen, let's say a couple of times here in Estonia, a question that has been asked. Let's say a person has been using an educational license while doing his or her studies, okay? and now intends to change to a business license, but not using the same Autodesk ID. So changing Autodesk ID, but wants to take the files over. What is the most reasonable solution or best solution in this kind of instance, let's say? Was it clear what I meant?
Yes. Yes, I understand.
Okay.
So your files are stored in Fusion Team, it's called. It's the cloud. And if you open your Fusion Team in the web browser, then it's possible to transfer all your data from one cloud to a different cloud. So if you have, so if you have an education license on your private email address, then you can move all the data from that account into a different account. That's possible to do.
Excellent.
Or you can also download a script. I have a script that will export all the files into your hard drive instead. And then you can upload it in a different cloud. So that is also possible to download locally to your computer. So it's how you would like to do it. But there are several options doing that kind of work.
Okay, thank you. So I think that would be all from our side. Thank you one more time. And we are heading now to the lunch. And I say we will make a small change in our schedule, let's say, for our participants. So we will continue at 1 o'clock. Okay? I think it's fine because we are a little bit behind of our schedule. And yes, so let's say we will continue at 1. Me jätkame kell 1, teeme natukene, ühesõnaga, mis te arvate muidugi, kell on 12:10, see on meie endi otsustada, tõtt-öelda. Et kas teeme lõuna või teeme 45, sest lõuna on siin samas, pole mõtet venitada, ma arvan. Kõik on selle poolt, ühesõnaga kõigile veebis osalejatele, et jätkame siis 12:45. Aga jätkame meie. Et kõik on ilusti lõunalt tagasi. Ma loodan, et online inimesed on ilusti tagasi. Pilt on ilusti ees, ma loodan, online'is ka. Et nüüd siis eesti keeles on meil 2 ettekannet teile välja pakkuda. Et esiteks olen mina ja siis räägitakse meil ühest teisest põnevast asjast veel. Et minu nimi on Tõnu Leemet. Kõige rohkem ma töötan õppijõuna tegelikult. Ja õppijõuna ma siis olengi õpetanud reaalprojekteerimist ja ka siis arvprogramm juhitavate pinkide programmeerimist. Ja ükskord mõned aastad tagasi selle kaudu me saimegi siis Ivariga ja AruCAD Süsteemidega saimegi tuttavaks, et tollel hetkel ma olin alustanud omal käel Fusioniga nii-öelda üliõpilaste harimist, nii reaalprojekteerimise kui ka CAM-i osas. Meil tekkis kontakt ja siis see kontakt arenes ja võt see kontakt on arenudki meie tänase koostöövormini, siis ütleme niimoodi. Ja see, mis ma mõtlesin, ma täna teile näidata tahaksin oma ettekandes, millest ma rääkida tahaksin, on see, et millised on olnud need tähelepanekud, olulised tähelepanekud selle teekonna jooksul, mil me oleme töötanud, mina olen töötanud Fusionit õpetades üliõpilastele, erinevatele teiste kõrgkoolide üliõpilastele, erinevatele ettevõtete inimestele. Et ma tahaksin need tähelepanekud kokku võtta ja esitada neid siis ühe või paari projekti taustal. Ja iga kell võite mind peatada, iga kell võite julgelt täiendada, kui midagi jääb segaseks. Sorry for those who don't speak Estonian. I apologize. This will be in Estonian. And if you see something familiar, if something raises questions in you, please don't hesitate to ask. Okay. So, the first, okay, sorry, eesti keeles ikka jätkame. Esimene ja kõige olulisem ütleme, et õppetund või arusaamise koht, mis ma olen tähele pannud, töötades inimestega, kes alustavad oma modelleerimise teekonda võib-olla, on see, et inimesed ei saa aru, mis vahe on 3D joonestamisel ja mis vahe on 3D modelleerimisel. Et eriti kohtub seda, ütleme siis võib-olla inimestele, kellel on tugev AutoCAD-i taust. Ja ka nende inimestele, kes võib-olla ei ole siis kõrgkoolis veel modelleerimisega kokku puutunud. Et need on erinevad loomad. Modelleerime me mudeli, me modelleerime keha, millel on ruumala, tal on veekindlus, tal on ka mass olemas. Versus see, kui me joonestame näiteks ruumi risttahuka, siis ta on suhteliselt elutu risttahukas. Tema ristlõiget ei anna teha, temaga ei anna midagi teha, ütleme nii. Ja siit edasi natukene, inimestel, kellel võib-olla see taust on puudulik, nüüd ma räägin nendest, kellel võib-olla üldse puudub igasugune joonestamise taust, siis inimesed pahatihti räägivad sellest, kuidas vanal heal ajal käidi lekaalikarbiga ringi, kaldpind oli, eks ole, erinevad paksusega harilikud pliiatsid. Kahjuks tänasesse päeva, kuidas öelda konverteerituna, pigem on oluline see, et inimene oskab aru saada, milline on hiire vasak klahv, milline on hiire parem klahv, mida tähendab üks vajutus, mida tähendab topeltklikk. Nii, selline üldine taust. Nii, nüüd ma tahaks näidata teile Fusioni pilti. Nii, ma näitan teile Fusioni pilti. See peaks tulema meil igal poole ette, see tuli ka siia igale poole ette. Kas keegi teab, millest programm Fusion 360 on oma nime saanud? Fusion, ka eesti keeles ma olen kunagi järgi vaadanud, tegelikult tehnika sõnaraamatus on olemas selline sõna nagu fusioon, mis ilmselgelt läheb kuskile osakeste füüsika maailma, kus mingid osakesed omavahel ühtivad. Ma tahaks kasutada sellist märksõna pigem nagu on integratsioon. Et Fusion mõnes mõttes tähendab integratsiooni päris mitmel tasemel, päris mitmel levelil. Esimene integratsioon on selline asi, et Fusion on võimeline kasutama väga mitmeid modelleerimise meetodeid, sealhulgas väga mitmete erinevat tüüpi mudelitega. Mida tähendab erinevad modelleerimismeetodid? Kõige elementaarsem modelleerimismeetod on solid modeling inglise keeles ja üleüldse me peame kahjuks laenama päris palju sõnu inglise keelest. Meil ei ole mitte midagi teha selles maailmas. Siis on olemas meil selline asi, nagu on meil pindmodelleerimine, surface modeling. Lisaks sellele Fusion suudab veel sisse võtta erinevaid asju. Ta suudab sisse võtta meshi. Meshil on ka eestikeelne nimetus. Kas keegi aitaks mind sellega? Kas ta on see mingi kolmnurk, mis iganes mudel või kolmnurk pindmudel? Meelis äkki? On mingi kolmnurk võrkmudel või midagi sellist. Ei päriselt, jah. See on üks tüüp, erinevad tüüpi. Lisaks sellele suudab Fusion modelleerida meil lehtmetalli. Fusion suudab töötada nii-öelda direct ja indirect moodides. See on üks level sellest integreeritusest. Teine level integreeritusest, teine tase integreeritusest on see, et Fusionis on mitmed meil töökeskkonnad, moodulid. Sama asi, et üks moodul on see, kus kohas me saame modelleerida, kus me loome geomeetriat ja muudame geomeetriat. Teine level on siis, näete, meil on seal erinevad animatsioonid, simulatsioonid, kuni siis CAM programmeerimiseni välja. Ja kolmas Fusioni integreerituse tase on see, et Fusionit on võimalik kasutada erinevates seadmetes. Meil siin on mul laua peal praegu PC, sama hästi võiks olla Mac. Lisaks sellele on võimalik teda, nagu meil on täna näidatud, võimalik kasutada ka mingisugustes tablettides, mingisugustes teistsugustes nutiseadmetes. See on see, kust Fusion saab oma nime. Mitu kihti integratsiooni erinevate asjade vahel, mida teha saab. Nii, ma vaatan, mul on väike kohaga ette joonistatud endal. Veel enne, kui me hakkame midagi konkreetsemalt vaatama, üks järgmine, kuidas öelda, küsimus või probleem, millega ma tihti inimeste õpetamisel kokku puutun, on see, et päris tihti küsitakse, et kuule Tõnu, aga kuidas seda on õige teha? Kuidas seda peab tegema? Vastus pahatihti on see, et ma ei tea. Asi selles, et modelleerimise maailmas, reaalprojekteerimise maailmas punktist A punkti B ei vii mitte kunagi üks õige rada. sa võid punktist A punkti B jõuda, ma ei tea, 9 erinevat teed mööda. Lahendusviise on palju. Ühte õiget, ma julgen arvata, et enamikul juhtudel ei ole. Võib-olla tõesti eksisteerib mingi soositum tööstrateegia, mida teinekord on mõistlik kasutada. Sellega ma tegelikult tahakski jõuda siis nende mõne näiteni, millega ma soovin teile demonstreerida mõnda aspekti ja samas ikkagi rohkem rõhutada neid probleemseid kohti võib-olla, millega me oleme kokku puutunud, et võib-olla algajate Fusioni kasutajatena, võib-olla siis ka kogenud kasutajana, kes hakkate harima teisi inimesi, kes hakkavad kasutama Fusionit. Et nendest minu märkustest võib-olla midagi võtta endaga kaasa ja teistele edasi anda. Nii, mul on valmis pandud, ma ei ütle, et need, vaatame, me peame ligi pääsema. Selle sealt lahti tegema, ma ei ütle, et need maailma kõige keerulisemad näited on või midagi sellist, lihtsalt näited, kuidas on saanud Fusionit kasutada. Esiteks, olgu märgitud, et kõik need mõlemad projektid on asjad, mida on päriselt vaja olnud. Näiteks see on üks masinaehituse detail. Selle masinaehituse detaili oli inimestel, ettevõttel oli sedavõrd vaja, et nad tulid sellega, põhimõtteliselt tulid õhtul korvpallitrenni järgi mul selle jupiga. Lihtsalt see on jutu jätkuks natuke soolakamaks teha seda näidet. Mis on oluline? Oluline, mida ma inimestele räägin, mis minu arust on probleemne, näiteks ongi see, et tunnetame, kui me õpetame 3D modelleerimist, tunnetame asjade 3D olemust. Tihti juhtub selline asi, et inimene alustab oma teekonda selles maailmas, vaatab asjadele risti peale kogu aeg. Kui sa vaatad 3-mõõtmelisele kehale risti peale, siis ta on meil ilus tasapinnaline asi. Sa ei näe, sa ei tunneta tema 3-mõõtmelist olevust, tema 3-mõõtmelist olemust. Nii, hüppame korra selle projektiga sinna, vabandust, üks samm edasi. Nii, mis meil selle näite mõte on? Selle näite mõte on masinaehitust, mis oli vaja järgi teha. Näite mõte on see, mis esimest korda nüüd iseloomustab seda sama integreerituse mõtet. Näete, siin on mul sisse toodud STL-fail. Siin on skänneriga sisse skänneeritud STL-fail ja veel olgu siis öeldud, et hästi peenikese võrguga. Hästi peenikese võrguga STL-fail. See on sellest esimene digitaalne mudel sellest failist, mida oli vaja järgi teha. Fusionis, muideks, on olemas, kes te kasutate Fusionit igapäevaselt, te teate, et Fusionis on olemas meil täiesti vahekaart, mille nimi on Mesh. Näete, Mesh vahekaardil on meil terve hulk tööriistu. Mesh on siis seesama võrkmudel, andke andeks, STL Mesh, ma nimetan neid ühte sama asju erinevate nimedega. Kus sa Fusionis saad seda töödelda, sa saad teda muuta, sa saad teda modifitseerida. Siin on küll nüüd see oluline asi, millega ma tahan sisse juhatada ühe järgmise, kuidas öelda, olulise kontseptsiooni on see, et erinevad tööriistad selles Mesh Workspace'is töötavad kas indirect või direct modeling režiimis. Et sellest tuleb aru saada ja mistõttu päris tihti uskuge mitte, inimesed on öelnud, et kuule, aga Fusion ei ole parameetriline 3D modelleerimisprogramm, mis on jumala vale. Fusion on täielikult parameetriline 3D modelleerimisprogramm. Ja sama eksitus võib tekkida selle koha pealt, et kui sa esimest korda tood Fusioni keskkonda sisse mingid sugused tüüpi faili, näiteks step-faili või seda sama STL-faili, siis Fusion käivitab ennast indirect režiimis. Meil ei ole seal sihukest asja nagu timeline'i, vabandust. Timeline'i meil ei ole all olemas. See on üsna oluline asi selles mõttes. Ja kohe ma pruvin selle timeline'i edasi ka, aga siin näide mõte on see, et tööb erinevat tüüpi andmeid. On võimalik neid töötlema hakata. Seda Meshi saab muuta. Meie täna selles näites muudame teda minimaalselt, me kasutame teda ära. Me kasutame teda ära ristlõigete võtmiseks. Selleks, et projekteerida see detail. Fusion ei ole otseselt reverse engineering või projekteerimise pakett, et siin on küsitud, et kas saab ka näiteks pindasid peale luua STL-failile, pindasid, nominaalpindasid. Ei, seda minu teada teha ei saa. Või ma ei ole sellest teadlik, ma tunnistan ausalt. Selleks on Autodeskil on teised programmid. Näiteks, mida täna ka mainiti, oli siuke programm, nagu oli see PowerShape. PowerShape on Autodeskil on siis nii-öelda dedicated reverse engineering. Nii, ma kruviin ta nüüd lõppu, selleks, et mitte väga toppama jääda siia, et siis projekti mõte oli see, et näete, kasutasime STL-i. STL-i pealt on võimalik, vaatame, kas meil õnnestub äkki demonstreerida ka kiiresti siit praegu. STL-i pealt on võimalik meil luua terve hunnik ristlõikeid. Vaatame, kas me... Selleks on head tööriistad olemas. Ma ei tahaks väga kinni jääda sellesse näitesse, siit võib-olla aru ei ole niikuinii väga midagi saada, aga see on täiesti võimalik. Nii. Ja liigume sellega edasi. On järjekordne point või siis märk, kuidas öelda, bullet. On see, et aga kuule, see alumine asi, mis on ajajoon. Et kes Fusioniga on rohkem tuttavad, teavad, et siin all on ajajoon. Ma teen sellest ajajoonest kiiresti ühe magnifieriga, teen ta kiiresti ühe selle ka. Et kõik saaksid aru, millest ma räägin, võib-olla kes ei ole ka Fusioniga nii tuttavad. Näete see asi siin all. Ma ei tea, kui hästi te näete siin, need ikoonid, eks ole, siis tähendavad meil ajajoont, timeline. Et kord öeldakse, et kuule, kui ma Fusionis midagi modelleerin, minu ajajoon läheb lootusetult segaseks kätte ära. Siin on see oluline asi, et tuleb olla teadlik sellest, milliseid tegevusi ajajoonele panna ja mida mitte. Näiteks inimesed kahjuks küll pahatihti kehasid liigutavad move käsuga, lootes niimoodi luua sõlme, mis on põhimõtteliselt vale, selle juurde me tuleme tagasi. Ja siis see tähendab seda, et see ajajoon on täis siin näiteks mingisuguseid neid move käsu ikooni. Tõesti võib-olla on keeruline aru saada. Olgu veel öelda, et seda ajajoont on tegelikult võimalik ka grupeerida. Tegevusi ajajoonel on võimalik grupeerida, rühmitada ka. Nii. Ja selle koha peal see näide suurepärast töötas. Üks asi, mis ma veel tahaks selle näite juhul rääkida, on see, et miks ma ta välja tõin siia, et siin on selle mudeli modelleerimisel on siis kasutatud veel lisaks sellele, et on meshiga töötatud, on kasutatud siia modelleerimise tööriistu nagu solid modeling tööriistad, on siin tegelikult kasutatud spin modelleerimise, surface modeling tööriistu. Sellepärast oli hea näide, kus need kõik koos töötavad. Aga Fusioni kontseptsioonis siia võiks ka lehtmetalli juurde panna, mida iganes, kõik töötab koos. Nii, järgmine oluline kontseptsioon. Ja ma ütlen ausalt, see on ikka päris oluline kontseptsioon. Sellest, kui saad inimesega kokku, kes on näha, et on Fusionis modelleerinud, on palju tutorialeid vaadanud YouTube'is, oskab modelleerimiskäsud on hästi, siis ütleme nii, et seda, mis asi on keha ja mis asi on komponent, seda loogikat, seda saab kõigile õpetada, ma ütlen ausalt. Fusioni mõistes on niimoodi, et kui me räägime sõlmest, kui me räägime koostust, kui me räägime mingisest asjast, kus on meil mitu detaili, elementi koos, siis me peame rääkima komponentidest. Fusionis seostatakse omavahel komponente, mitte kehasid. Me oleme näinud üks üsnagi tuntud mööblitootja. Ühel hetkel küsis nõu millegi kohta ja siis ma avastasin faile läbi käies, et seal olid terved need, seal oli ikka palju, ütleme mõni kuni 100 komponenti, ma arvan, oli selles mööbli esemes. Ja need kõik olid omavahel siis nii-öelda bodide kehadena, kes Fusioni loogikat teab, kehadena muu käsuga kokku hekseldatud, mis põhimõtteliselt ei ole õige. Mida tähendab, vaadake, selles liikumine tähendab seda, komponentide vaheline liikumine, näed, üks komponent määrab selle, kuidas teine liigub, neil on omavaheline seos. On sõlm. See on lihtsalt praegu üks mingisugune näidissõlm, mul siin lasta olla, mingisugune nii-öelda käigukasti või reduktori alge. aga mõte on siin selles, et kui te kasutate Fusionit, kui te õpetate teisi kasutama, komponentide loogika tuleb endale kohe alguses kasutusele võtta, tuleb endale selgeks teha. See on oluline. Nii, selle koha pealt see oli see näide. Siis liiguks veel edasi korra. Nüüd ma tahaks demonstreerida seda integreeritust. Me oleme praegu rääkinud integreeritusest, sellest, kuidas Fusion on võimeline kasutama erinevaid modelleerimismeetodeid ja erinevaid tüüpi mudeleid on võimeline kasutama. Nüüd tahaks rääkida sellest teise taseme integreeritusest, et kus meil on siis mitu töökeskkonda on ühte paketti kokku toodud. Näete, meil oli seal disain on see koht, kus me loome ja muudame geomeetriat ja nüüd on meil olemas selline koht nagu manufacture, kus me saame midagi reaalselt valmis teha. Ja valmis me ei saa teha ainult niimoodi, läksin kogemata valesse kohta, et Fusion ei toeta mitte ainult füüsikalisi lõiketöötlemise protsesse, nagu on freesimine, treimine, vaid Fusionis on olemas siis ka tööriistad igasuguste kahemõõtmeliste pinkide, lõikepinkide, vesilõikurite, laserlõikurite programmeerimiseks. Samuti on Fusionis võimalik tegelikult ka luua tööradasid 3D printerile. Fusionis on täiesti sisse ehitatud slicer. Et täiesti toimib, oleme seda teinud ka. Nii, vaatame, siin ma lihtsalt võtsin praegu, tegin ausalt öeldes ühe täiesti meelevaldse, ühe kunagi ühele meie ülikooli kõrgele ametnikule tehtud töö. See seisnes siis, ühesõnaga igasugune autorestaureerimine on tema hobi ja siis seda teate, et autorestauraatorid ei räägi mitte kunagi kõva häälega sellest, kui mingi jupp on järgi tehtud. Sellepärast, et see ei ole enam restaureerimine. Restaureerimine on see, kus sa suudad leida selle automobiili autentse jupi või parimal juhul siis selle B-varu osa. See, et keegi sul skännib ja välja freesib jupi, see on, seda tehakse, aga see ei ole õige. Aga siin siiski on ühesõnaga üks jupp ja antud hetkel ta töötab selle jaoks, et näidata meile seda, et tõepoolest näete, meil on siin kämm olemas. Kämmist meile räägiti täna palju. Meile räägiti täna kämmist palju, see on siis RAL, programmeerimine, eesti keeles RAL tootmine. Siin on üks küsimus näiteks selles valdkonnas päris tihti, mida kohtab. Et öeldakse, et kulaga selle Fusioni standardpaketiga ei ole põhimõtteliselt võimalik midagi programmeerida. Mis minu hinnangul jällegi ei vasta tõele. Fusioni standardpaketis on, mis puudutab näiteks freesimist, siis 3-teljelise freespingi töörajad. Ideaalne. Treimine, vähemalt ütleme kuni aktiivinstrumendiga treimiseni, ehk siis 2 telge, XZ, programmeeritav C-telgi aktiivinstrument, samuti ideaalne. Miks ma sealt edasi ei oska rääkida, on see, et mul edasi enamate telgedega mul puudub austada isiklik kogemus. Aga olen aru saanud, et inimesed on korda saatnud suurepäraseid asju seal. Siinkohal tahaks natukene juttu nüüd täiendada veel. Vaadake, meile räägiti täna mitmes kohas, räägiti meile siis sellistest asjadest nagu need lisamoodulid, extensionid. Et jällegi oleme kuulnud väidet, kus öeldakse, et kuule, Fusion on selles mõttes jah, tema baaspakett võib-olla on tõesti sõbraliku hinnaga, aga kui sa päriselt midagi tahad, siis sa pead hakkama raha maksma nende extensionitest. Jällegi see ei vasta tõele, et näiteks kui me räägime siin kämmis olles on olemas selline asi nagu machining extension. Machining extension annab meile siis mingisuguse hulga täiendavaid tööradasid. Näiteks on seal tõesti selline töörada nagu steep and shallow, mis on väidetavalt siis üks universaalsemaid puhas töötluse tööradasid, mis kujutab siis endast 3D freesimise maailma puutuvaid asju. Kui te töötlete näiteks vorme, kui teil on vormid, kus teil on mingid pinnad, mis ei ole rangelt horisontaalsed ega vertikaalsed, mingisuguse imeliku kõvera kujuga, imelike nurkade all omavahel, siis näiteks on selline töörada seal olemas. Näiteks on machining extensionis on olemas selline võimalus, kus sa saad neid tööradasid trimmida. On üks võimalus. näiteks on machining extensionis olemas selline asi nagu surface inspection täiendmoodul, kus sa saad, ütleme nii, et kui teil on CNC tööpingis on teil sees siis probe või mõõtepea, siis teil on võimalik läbi Fusioni programmeerida oma CNC pinki niimoodi, et ta kontrolliks teil kohe teie poolt töödeldud pinna kvaliteeti, kasutades seda probe'i. See on üks asi, mida on seal võimalik teha. Jah, ma ei hakka praegu tööradade programmeerimisse minema. Tööradad selles mõttes täiesti olemas ja ma tahaks veel laiendada seda juttu natukene nende extensionite teemal, et veel üks extension, mida me oleme tutvustanud inimestele, on näiteks nesting and fabrication, et siin oli esimeses ettekandes meil räägiti nestingust, mis asi see on, põhimõtteliselt nesting võiks olla siis ma ei tea, lehtmetalldetailide või siukse lõikedetailide jaotamine siis toorikute peale ja nii edasi, et Fusionis on see täiesti olemas, see täiesti töötab. Paneme mingisuguse tööraja käima ka, vaatame, kas ma ütlen teile ausalt suhteliselt vana fail. Ta tahab hakata seda masinat siia sisse tooma, las ta võib-olla jääb praegu. Te olete, ma usun, et paljud teist on kämmi näinud küll. Nii, vot nendel tasemetel mina tahtsingi austuseks tegelikult minu tänase ettekande tuum oligi selles, et tunnetada seda integratsiooni mitmel levelil. Et kindlasti ma ei läinud praegu ajast ja mul isegi tugevalt siin üle, mitte mingitesse detailidesse, aga see, et meil on olemas võimalus töötada erinevat tüüpi andmetega, võimalus kasutada erinevaid modelleerimismeetodeid. Meil on ühes paketis koos erinevad siis üritan selle kinni saada, don't show me this, erinevad töökeskkonnad nagu manufacture, animation ja nii edasi. Ja siis vaatasime seda manufacture näidet. Et mul ei ole hetkel, ma ei pidanud vajalikuks koostada näidet selle kohta, kuidas kasutada Fusionit erinevates seadmetes, seda meile tegelikult täna näidati. Et on olemas siis võimalik läbi brauseri jagada, näidata ka Fusionis tehtud mudelit. Minu teada töötavad seal samamoodi need markupid ja neid, mida näidati. Peaks saama teha ka nii, et ma jagan endale siit mudeli, võtan endale telefoni kätte ja ma saan põhimõtteliselt või keegi teist, kelle ma saatsin selle, saab ka mudel, seda vaadata kindlasti. Ma usun, et seal oli ka see markup võimalus olemas. Vot, et see oli see sõnum, mis ma teile soovisin edastada. Ja koos siis nende fundamentaalsete nõuannetega, mis eriti puudutab seda, et kes Fusioniga töötab, komponentide loogika tuleb endale selgeks teha. Ja üks müüt veel, mille ma lõpetuseks tahaks ära kummutada, on see, et Fusion vajab töötamiseks alati internetiühendust, ei vaja. Tegelikult sa saad Fusioniga töötada ka ilma internetita, lihtsalt toimub see, millest räägiti, et ükskord, kui see interneti saab, siis sul põhimõtteliselt need failid selles mõttes tõesti laotakse pilve üles sellel hetkel. Vot, minu poolt ametlikult praegu kõik, et läks lühemalt, läks oluliselt lühemalt, pole hullu. Võib-olla kasutame aja ära ja teiepoolsed küsimused, palun. Kas või nende näidete kohta, millegi muu kohta, palun, kui ma oskan vastata. Kui ei oska, siis leiame. Ja, Meelis, ma näen.
Küsimus on komponentide kohta, et ma olen
Teeme väga lihtsa näite. Teeme siis laivis, kui teistele sobib, kulutame selle aja, teeme väga lihtsa näite. Niimoodi näete, ma võtan siit lahti praegu, teen ühe näite. Selles jällegi ma tahan demonstreerida teile Fusioni võimekust töötada erinevat tüüpi failidega. Ma toon siia praegu näiteks, sisse, teeme siia siis lehtmetallkomponendi, teeme siia create new component, teeme siia lehtmetall-detaili, las ta jääb täpselt selline, nagu ta on. Joonistame sinna kiiresti. Ma mõõtmeid ei hakka praegu panema, ärge mulle palun keegi pahaks pange seda, või soovite näha, 85 korda 100. Anname talle mingisuguse paksuse ka, okei, teeme talle mingisugused painded ka külge. Nii, teeme sinna ka ühe väikse paindekese. Niimoodi. Põhimõtteliselt tema on meil komponent, kuna ma just alustasin ta komponendina. Niimoodi, tema on meil komponent. Näed, komponent liigub ringi. Ma võtan tast kinni, komponent on vaba, ta liigub ringi. Nüüd näiteks, ma teen sinna ühe tavalise solid keha. Lähen teen sinna ühe tavalise solid keha, lähen teen näiteks sinna samma, panen revert position, lähen joonistan sinna mingisuguse teise keha, tavalise solidi, näiteks sellise. Läheme teeme tast mingisuguse, võtame sealt symmetric, nii kindlasti, et oleks meil keha, body. Nii, ja kui ma nüüd seda elukat üritan liigutada, tema ei liigu. See on esimene oluline selles mõttes, see on body. Vaatame, ma üritan korra sisse zoomida, niimoodi, näete, ühesõnaga Fusionis, kuidas mina seda õpetan, vähemalt seda osa on asi väga lihtne, tuleb jälgida neid ikoone, mis meil on data browserid. Kui meil on data browseris, seal näete see ikoon, kus meil on risttahukad üksteise seljas, see ütleb seda, et tegemist on peakomponentiga, main component in English. Ja sama sees elavad meil teised komponendid. Näete, kui ma data browserist vaatan oma kehade kataloogi, näete, keha ees olev ikoon on selline. Kehad ei liigu, tema on meil keha, inglise keeles body, no mõnikord ütleme eesti keeles ka mudel, ta ei liigu. Ma tahaksin teda liigutada, kui ma tahaksin move käsuga, aga see on niimoodi, et tema jõuga liigutamine, see ei ole see, kuidas Fusion on mõeldud töötama. Fusion on mõeldud töötama niimoodi, et komponent liigub. Vabandust, teeme ühe näite veel, nii jätkan. Ma vist hävitan selle keha ära üldse. Kas näiteks, kas teatakse, mis vahe on käskudel delete ja remove? Remove on selline asi, mis loob meile sisendi ajajoonele, panite tähele, mul tekkis ajajoonele sisend. Mul tekkis ajajoonele tekkis sisend, märge, ehk ma võiks minna seda tegevust muutma, tagasi võtma, versus delete midagi sellist, mida ma ühel hetkel enam tagasi võtta ei saa. Nii, ma teen siia kiirelt sellise asja, et läheme teeme sinna ikkagi. Kui teile sobib, me teeme seda. Ma nüüd natukene rabistan, teeme sinna kiiresti ava sisse, näiteks selle samase ava 10 milli suvalise koha peale las olla, näete, meil tegime oma lehtmetalli. Ahah, ma tegelikult tahaks näidata, mida tähendab lehtmetalldetail. Lehtmetalldetail, näete, on selline asi, et seda lehtmetalldetailis saab teha näiteks pinnalaotuse. Pinnalaotuse niimoodi, selle pinnalaotuse järgi saab teha DXF-faili, selle saad saata otse laserpinki painutusse, mida vaja on. Nii ma panen ta kinni, see on see, miks ta on lehtmetalldetail. Nii, nüüd ma tahan siia sisse tuua ühe välise komponendi. Ma toon siia kiiresti sisse välise komponendi, Fusion kasutab siis insert master car, nii-öelda seda, lähme toome sealt ühe meetrik, M10 boldi sisse. Nii, M10 meetrik, ma võtan suvalise, andke andeks mulle, selles mõttes meil tegutseme siin, meil on ikkagi aja peale, las olla, nüüd võtsin mingi täiesti vale asja. Headless ei ole päris õige asi. Nii, vaatame, kus ma näen neid, kus 12 millimeetrit, see ei sobi millegi pärast. No võtame selle sama siit. Nii, vaatame, kas me saame tema CAD mudeli, 3D step download sobib praeguseks hetkeks. Näete, teen välise komponendi, toome sisse siia ja paneme ta sinna. Nii, näete, temaga liigub. Praegu nad mõlemad liiguvad. Ja Fusioni loogika on selline, et kui ma tahaks nende vahele seost luua, siis meil on assemble menüüs, on meil joint tööriistad. Joint tööriistadega lähme, rabame kinni näiteks sellest punktist sealt. Läheme seostame selle pidepunktiga ehk joint originiga seal. Ja palun väga, see on see, kuidas asi toimib. See on see, kuidas me peaksime sõlmesid modelleerima. Ma loodan, et see oli vastus sinu küsimusele.
Ja, praegu see feature puuk on.
Jah.
On see kõik nagu asset?
Okei, võib-olla see asi ka siis, et Fusioni fail ongi koost. Versus see, et kellel võib-olla on taust teiste modelleerimisprogrammidega, kus me alustame detaili modelleerimist, meil on eraldi detailifailid ja siis tõstame nad kõik kokku eraldi koostufaili, siis Fusionis on üks fail. See on koostufail, kus detailid on vaikimisi juba sees. Top down. Ma loodan, et see vastas su küsimusele.
Ja, et kui ma teen teise toote, kuhu see toote sisse läheb.
Siis sa saad välja selle, siis sa saad selle nii-öelda assemblina saad siit välja võtta, kuhu sa saad sisse pannada. Ja siis sa saad valida, et kas ma tahan seda sõlme hoida selles uues sõlmes elavana, mis tähendab seda, et kui ma nüüd originaalis lähen seda sõlme muutma, see muutus läheb mul sellesse uude sõlme edasi. Või ma võin selle nii-öelda sideme, selle parent relationi võin ka nii-öelda katkestada, kui ma tahan seda. Nii, palun, kas meil on veel küsimusi? Veelis? Saan ma sind veel millegi aidata?
NetFabi funktsionaalsusest. Kuidas see NetFab siin esindatud? See on see additive manufacturingi moodul.
Yes, manufacture, siin on meil manufacture'is on meil olemas additive. See on see kõik, mis on vaikimisi olemas, aga kui me rääksime ennem extensionitest, siis 3D metal printing extension on ka üks eraldi extension ja ma usun, et see kasutab võib-olla rohkem seda NetFabi. Aga tunnistan ausalt, et ühe korra elus olen slice'inud Fusioniga või paar korda. Et mitte sellepärast, et ta ei töötaks, vaid lihtsalt võtted on sellised, et on harjunud teistmoodi tegema. Selles on asi.
Lihtsalt NetFabi eraldi. Kui printisime sadu detaile koos, siis tal oli see, suutis ära jagada detailid panna paika kuubikus 3D-s. Kas siin see funktsionaalsus on olemas või pigem siin ei ole, et NetFabis eraldi?
Ütlen ausalt, jään vastuse võlgu. Võime pärast päeva lõpus küsida välismaa kolleegide käest. Ei ole isiklikult kokku puutunud. Nii, soovib keegi veel lisada, täiendada, kommenteerida, küsida. Võib-olla keegi meie online publikut, palun. Vaatame chati korra. Chatis me ei näe mitte ühtegi küsimust praegu. Julgemalt, palun, inimesed. Julgemalt.
Okei, üks küsimus. Kui keegi taha küsida. Küsiks seda kämmi mooduli kohta, et tööriistade raamatukogu library. Seda saab ise endale lokaalselt.
Absoluutselt, niimoodi.
Mitme kasutaja peale lühim ka.
Jaa.
Ettevõtte oma näiteks osad on midagi taas.
Nii, ma võtan siit mõne kämmi lahti, mis meil mõni viimane kämm. Noh, siin on üks üsna labane. Vaatame, seal vist ei olegi tööradasid peal ausalt öeldes. Seal ei ole ühtegi töörada peal. Noh, siin tegelikult on töörada peal, võtame selle. Niimoodi, siin on meil peaks töörada peal olema, peaks töötama ka. See on näide sellest, kuidas tuli just eelmisel nädalal tuli VDI 40 jaoks ehitatud treimise tööriist tuli üle treida selleks, et seda saaks kasutada VDI 30 turretiga CNC treipingis. Ühesõnaga, asi on lihtne. 25. teidera tuli lasta 20 peale, see on see tegelikult see töörada siit, näete. No laseme selle simulatsioonis ka korra läbi ja siis jõuame sinu küsimuseni ka. Niimoodi vaatame simulate, et võib-olla siis kes ei ole selle asjaga kokku puutunud, et seda simulatsiooni tegelikult oli siin palju ka, et ma kiiresti räägin, et see asi on siin siis tööriist, on siis meil freesimise protsessi simulatsioon, kus meil siis tööriist, mis meil on sinisega, on siis nii-öelda nihke liikumise kiirusega liikumised. Kõik, mis meil on kollasega, on meil kiirpaigaldusliikumise kiirusega vahepaigaldused. Kõik, mis meil on siin rohelisega, need on siis lõikesse liikumine, lõikest välja liikumine. Et selles mõttes Fusion teeb selle puhul. Nii, küsimus oli meil tööriistadest ja minu vastus on, et saab küll. Jah, saab küll tiimis jagada neid absoluutselt katalooge. Nii, mul endal ei ole ühtegi tiimi, ausalt öeldes, kus ma töötaksin. Sellepärast mul siin ei ole, aga ma usun, et täiesti saab. Just nimelt ja cloud tähendab seda, et ta on põhimõtteliselt nii-öelda minu kontoga seotud, aga ma usun, et sa saad selle teha seotuks ka oma tiimiga. Ma natuke kogutan, sest mul ei ole, kuna ma olen selline eraklik selles mõttes Fusioni kasutamise mõttes, no päriselt ei ole vajadust olnud üheski tiimis olla, siis ma ei ole saanud ühegi tiimiga nii-öelda jagada Fusioni tööriista kataloogi.
Eeldavast teemast oli juttu, palju tööriista on võimalik erinevaid konfiguratsioone salvestada erinevate materjalide jaoks ja erinevate olukordade jaoks.
See on väga... No näiteks ma võtan lahti ühe viimase tööpingi, millega siin ühesõnaga olen kokku puutunud, üks haasipingikene, üks uuem ühesõnaga. Võtan lahti näiteks selle tööriista, mis on saanud sinna luua, see sama koht, kus on cutting data, näed see sama koht, kus on preset, add preset, nimetame selle näiteks öpikumaja preset, okei, see on liiga naljakas, paneme plast või? Paneme sinna näiteks plast, nüüd panen paika oma lõike kiiruse, plasti lõikime 150 meetriga minutis, et nihet hambale paneme näiteks 0.1, põhimõtteliselt accept. Järgmine kord, kui ma seda tööriista kasutan kuskil, on mul alati valida kohe need kaks nii-öelda seda sama. Meie nimetame neid profiilideks, me nimetame neid lõikeparameetrite profiilideks. Aga jah, see on täiesti olemas. No nii.
Kui nüüd output ei ole töökäes masinad, peab olema joonis, võimalustest selle jaoks tükitabeli loomine.
Tükitabeli loomine töötab suurepäraselt, kohe demonstreerin. Niimoodi, võtame selle sama asja, mis meil siin on. Ütleme nii, et meil on siin olemas kaks komponenti, teeme kiiresti ära. Esimene asi, mida Fusion tahab saada, ta tahab kindlasti, et see asi, fail oleks salvestatud enne joonise loomist. Nii ma panen talle nimeks Demo 21 läks niimoodi. Kui ta on meil salvestatud, siis näete, meil ongi see sama integreeritus mitmel tasemel. Siin on olemas drawing from design, vabandust, oleks nüüd valida. Nii, siit vaatame kiiresti, paneme paika talle sobiva lehe, jääb täna A3. Laks olla, praegu kiiresti teeme siin. Nii. Avaneb meile täiesti uus fail, siin on siis tegemist, paneme mingisuguse, võtame selle isomeetrilise näiteks täiesti ja teeme ta suuremaks ka. 1.1 näeb välja selline, no ei ole kõige parem valik. Teeme näiteks Northwest, see on palju parem valik. Läheb sellega praegu paika. Niimoodi, see on meil koostuna. Nii, okei. Nii, siuke asi nagu insert tables, parts list, loistan sinna paika. Keegi kolleegidest muideks, kui panite tähele, üks välismaalane, see oli Raikard, kes ütles, et kui ma loodan, et temani jõudis küsimus õiesti kohale tegelikult. It was you who asked what are the possibilities in Fusion compared to Inventor when composing the drawings. And I think Raikard answered that they are roughly the same. Paul, am I?
Roughly, yeah.
Yes, in principle, in core level, they should be the same. I believe there might be some more detail. Nuance, detail, more detail in Inventor when compared to Fusion. It's my personal opinion.
I think the one big difference is the ability to use overlays in Inventor, so you can use model definitions. So, for example, JCB digger, you could have a view of the digger with the buckets fully back.
Okay.
Using the design views from Inventor and the overlay command, you can then have literally over top of it, the extended version of the bucket, so you can compare the two on one view.
Okay. No, ma vastaks ühesõnaga eesti keeles kokkuvõtvalt, et põhilised tehnilise joonise loomise võimalused on absoluutselt olemas, selles pole küsimustki. No, et see oli meil koos tükitabel, kõike saab muuta ka. Ja. Nii. Kas ma saan veel millegagi aidata või nüüd me oleme selles mõttes täpselt ajagraafikud jälle, et haksime edasi minna järgmise ettekandega. Et küsige julgelt, võtke julgelt Ivariga ühendust, kui on küsimusi.
See küsimus, et praegu vist ei ole mõeldud, et ühes ettevõttes mõlemad nii Inventorid kui Fusion kasutuseks võib-olla, et disaininžener töötab inventoriga ja tehnoloog töötab.
Ei, ma see...
Eriti kui need kasutaks Vaulti, et siis kuna see Fusion Vaultiga ei suhtle.
Vabandust, ma vahele segasin. Tead, selles mõttes, ma ütlen, ma ei ole see inimene vastamaks sellele päris täpselt, aga ma natuke julgen argumenteerida vastu, et miks mitte. Et ma arvan, et väga hästi saab selles mõttes koos töötada nendega just tänu sellele, et võib-olla nad täiendavad teineteist. Aga võib-olla see küsimus äkki võib-olla järgmisele ettekandjale ja võib-olla ka pärast poolile, sest Vaultiga on mul 0 kogemust ja samamoodi inventoriga mul on minimaalsed kogemused. Nii, aga kas on nüüd see hetk, kui ma tõmban ise joone alla oma jutule ja me liigume edasi järgmise ettekandega? Jääb siis järelikult nii. Niimoodi. Jaa. Ma loodan, et veebis on ka kõik meiega veel, et olemegi sujuvalt jõudnud siis praegu viimase ametliku ettekandeni. Et Mati, palun, sõna on sinul, et Mati räägibki meile kõigepealt iseendast natukene ja siis räägib ka Autodesk Vaultist. Ja, mida te kõik olete oodanud pikka silmi. Nii, see juhe oli sul olemas, eks ole. Nüüd ma ootame väikse hetke, kui sa saad enda selle taha siia. Sul on see klikker taga. Ja.
Alustan ühe videoga hetke pärast. Niisiis, tere, mina olen Mati Link. Mõned on tuttavad näod siin aegade jooksul. Et minu CAD-i kogemus hakkab aastast 2000 kuskil, kus esimeseks töövahendiks oli õnneks. Nad olid just vahetanud välja AutoCAD 2D ja sain alustada AutoCAD Mechanical Desktopiga, Desktop 3-ga. Ehk siis noore poisi jaoks, kes on õppinud koolis 3D modelleerimist. See hirm läks napilt mööda, et pidi 2D tegema hakkama. Ja Mechanical Desktop on selline väga sarnane kaasaegsele, et sketš ja feature ja nii edasi. Siis minu elu hakkas sealt niimoodi peale konstruktorina. Ja aegade jooksul võtsin hästi palju sõna selle kohta, et miks meil on mingi käsitöö siin, miks me topeltklikke teeme, miks me copy-paste'i teeme, miks meil ei ole mingit ühendust andmebaasiga. Siis aegade jooksul tänu sellele liikusin sellisesse nagu CAD-i arendamise alale. Ja nüüdseks olengi siis aastaid juba erinevate PDM-idega tegelenud. Kogemusi on mitmetega. Nüüd siis inventorist rääkides. Siin on üks selline näide ühest meie välismaa kolleeg siin oli teinud sellise toreda masina, mida tema 2 poega seal, millele kaasa elavad. See on hea näide sellepärast, et teha midagi sellist tõsist, isegi võib-olla väiksema tiimiga on faili haldus ja nagu näete, siin on vaja teha igasuguseid simulatsioone, tõgusarvutusi, et see õige viimane versioon alati saaks nagu jagatud üksteisele. Et nii tõsiste tööde puhul on igal juhul andmehaldus ja lisaks heale modelleerimisele kasulik. Okei, nii palju siis sellest. Aga minu esitlus täna võib olla päris tihe, kuna kavatsen rääkida päris mitmest sellisest teemast, mida PDM süsteem ehk Vault teile annab. Nii et ma loodan, et ei ole väga unised pärast seda lõunat ja panen käima. Nii et lihtsuse mõttes, kiiruse mõttes mul on siin videod, aga räägin peale. Nii see esimene teema on siis see, et kuidas see PDM süsteem on CAD-iga täiesti integreeritud. Nimelt sisse logides on võimalus kasutada mitmeid erinevaid kasutajatüüpe. Hiljem ma näitan neid ka täpsemalt, aga nagu näete, siin on selle Vaulti enda oma, võib kasutada Windowsi kontot ja ka siis Autodeski ID, et süsteemi sisse logida. Ja avamisel on suhteliselt tuttav keskkond ilmselt teile inventori kasutajatele. Nimelt saate mööda katalooge brausida, saate näha eelvaateid ja nüüd PDM-i puhul tuleb selline huvitav teema ette. Nimelt, kui komponendid on uuemad kui koost, siis seal all on võimalus avada koos sellise pildiga, kuidas komponendid olid koostusalastamise hetkel. Või teine variant, avada täna koost nii, kuidas eile tehti mingisugused komponendid ümber või uuemaks. Niisiis, PDM-is on väga tähtis see eelis, et kui te näiteks kasutate mingisugust pilvetarkvara nagu mingisugune Dropbox näiteks, siis te saate küll vana versiooni juurde tagasi minna, aga Vault annab teile võimaluse võtta see koost näiteks lahti koos referentsidega, nii nagu ta nägi välja eile või mingisugusel muul ajahetkel, nii nagu et ka referentsid samal ajahetkel. Ja siin pildil praegu hetkel näete võimalust siis erinevat infot omale siia välja tuua selleks, et faili avada. Nimelt, see on andmebaas, kõik failid, mis te sisse panete, nende kohta tekitatakse väga palju infot. Ja kõik seda infot, mis süsteem on genereerinud ja teie käest vastu võtnud, saab siin väga kergesti siis kasutada asjade avamiseks ja otsimiseks. Kui me aga mingit tööd teeme, midagi modelleerime, siis kui teil on, ütleme, praegusel juhul failid võruketta peal ja mitme isikuga jagatud, siis pigem kehtib see, et kes SMS, kes ennem saab faili lahti, sellel on kirjutusõigus. PDM-i puhul on üks eriline käsk, mis tuleb juurde, nimelt checkout. Siin hetkest, kui ma avasin seda koostu, siis süsteem küsiski, kas ma tahan võtta sellele checkout'i ehk kirjutusõiguse. Aga siin on näha teisi käske, mida meile PDM-süsteem annab, et tööd paremini teha. Nimelt, modelleerimine ja CAD on täpselt sama. Te teete oma detaile, simuleerite, panete kokku, teete jooniseid, nii nagu tavaliselt. Aga andmebaasi haldus annab teile juurde siis selliseid mõningaid väga vajalikke käske. Võiksime siit nendest kiiresti üle käia. Näiteks refresh file, see annab teile on ise ennast selgitav, eks ole. Siis revisionidega teeme hetke eest ühe testi, demonstreerime seda. Joonis avamine muidugi. Ja joonis avamise puhul on tore see asi, kui sa liigutad kogemata joonise või mingisuguse kas või koostureferentsi, koostukomponendi teise kataloogi, siis PDM igal hetkel teab, kus on ja leiab need asjad ülesse. Siis on siin muidugi check-in, check-out'i teemad ja revert to latest ja check-out on nüüd need teemad, mis puudutavad disaini muudatusi ja revisione, mida me kohe näitame täpsemalt. Järgmisena on duplikaatide otsimine ja muidugi undo checkout. Algajatel tuleb alati, kuna iga muudatus jääb süsteemi alles, siis võib-olla see on algajate küsimus, et mis siis saab, kui ma teen mingi muudatuse ja ma enam seda ei taha. Näiteks, kui sa oled alustanud mingit tööd mingi asja kallal, siis on alati võimalik võtta undo checkout ja väga lihtsasti kaotada see ilma asjata tehtud töö ära. Find duplicates. No väga tähtis on see, et ei oleks sama nimega faili erinevates kataloogides. Vault süsteemis saab muide selle keeluga peale panna, et igal failil oleks oma unikaalne nimi alati, kui need duplikaate siin on, kui olete vana disaini tõmmanud sisse, siis on väga kerge käsuga võimalus need ka üles leida. Ja väga tähtis asi on kategooriad. Kategooriad näeme ka pärast hiljem veel korra. Kategooria nimelt on selline nagu faili tüüp, millest sõltub selle faili käitumine selles süsteemis. Kas tal on ühtemoodi või teistmoodi reeglid, datakaardid ja muidugi disaini kopeerimine. Datakaardi vaadates saame esile tuua kõik sellised parameetrid, mis on sellele detailile antud, nimetused, materjalid, tüübid, kõike saab veel muuta. Ja kui teil on vaja üle vaadata detaile, mis on seal selle koostu peal, siis selle sama aknaga saab kergesti vaadata kõigide detailide selliseid nimetusi ja parameetrid. Nüüd nendest käskudest, mis meil siin üleval on üks teine aken, millega saab näiteks näha selle detaili revisione. detail on valitud ja siin on näha, et temast on tehtud A ja B revisjon juba. Ja nende revisjoni mõte on siis selles, et näidata disaini ajalugu ja hiljem on ka võimalus ajas tagasi minna mingi vana revisjoni lahti võtta. Üks huvitav ülevaade, üks huvitav võimalus tuli päris hiljuti, nimelt sellised graafikud info kohta, info PDM-i, kuidas ma ütlen, PDM-i info graafiku kujul. Näiteks antud koostöö puhul on päris hea ülevaade sellest, kui kaugel on minu töö, mitu komponenti on valmis, ehk siis reliisitud, ütleme heakskiidust läbi käinud ja mitu komponenti on siis töös. See on väga hea ülevaade enda jaoks, mitte ainult ülemusele vastamiseks, et kaugel sa oled, vaatad järgi, kui kaugel sinu tööjärg on. Siin on veel kord datasheet ja kui me vaatame komponente, siis üks asi, mis PDM meile annab, on nimelt kuuluvus. Iga hetk, kui sa paned komponendi või koostöö PDM-i, loeb PDM välja need referentsid ja valides ükskõik millise komponendi, ilma otsingut käivitamata, ilma aega kulutamata, teab kohe, missugusesse koostöösse see kuulub. Nagu näete, et detail kuulub esimesse koostöö, see kuulub eelmisse koostöö, kolmandasse koostöö, ehk siis peakoostöö välja. Ja see detail ise veel kuulub ka enda joonisesse. Sellised referentsid on igal ajahetkel siis andmebaasi süsteemi poolt saadaval. Ja paremal liigub selline, paremal liigub selline andmebaasi jälle ülevaade sellest komponendist, mida me uurisime. Ette siin selle pool. Jah, kerge käsu võib hüpata sellesse kataloogi, kus see fail asub, mis meil tulemusena ette tuli. Ja siin me näeme nüüd selle koostöö eelnevaid versioone. Nimelt iga check-in, iga töö tagasi süsteemi panemine tekitab sellise ajaloo versiooni näol. Me saame alati tagasi minna, neid vaadata või siis nende peale tagasi minna, kui tuleb välja, et mingi disaini variatsioon ei tulnud meile sobivalt välja. Niisiis, see info tuleb kõik inventorist tavapärase tuttava praeguse töö põhjal. Selle sisestamiseks ei pea te midagi juurde tegema, aga see võetakse sealt välja, antakse teile kasutamiseks. Järgmine võiks olla kiire otsing. Vaatame, millisel moel PDM-süsteem aitab meil faili otsida. Kui praegu te midagi otsite Windowsist, siis võtab alati see mingisuguse aja. Windows peab indekseerima mingid failid, leidma ja enamasti see otsing käib faili nimede järgi. Kuid siin, nagu näete, otsinguks sai pandud bearing on ju ja sellel komponendil oli see bearing hoopis kirjas sellises nagu parameetris või properties. Teine viis otsida muidugi on kõikide erinevate propertite järgi, näiteks kui ma panengi kohe, et otsi description väljalt bearingut, siis me saame ühe selle konkreetse faili kätte.
Küsimus vahel. Kus siin see töötab ainult Autodeski toodetega või ükskõik mis faile sa haldad selle Vaulti?
Ükskõik mis fail, sest Vaulti on olemas, esiteks saab erinevaid käede sinna sisse panna, nende jaoks on olemas add-inid ja siia saab ka panna kõige suuremaid Office'i programme. Ehk siis propertite nagu tehnoloogia on Windowsis kuidagi selline nagu universaalne, et siis näiteks Office'i propertid ja selle inventor propertid on kättesaadavad samal moel. Nii et kui sul oleks näiteks mingisugused Wordi dokumendid, siis nendel oleks samasugused propertid, saad neid samamoodi otsida. Seda küsisid?
Jaa, muudes seda, kui on näiteks ainult käemudelit, mida haldab toote kõikide andmeid, seal võivad olla mingid kas või emailid, seotud selle asjaga ja mingisugused arvutusmudelid ja tabelid ja kõik asjad peavad olema seotud.
Selle süsteemi ülesehitamisel seatakse erinevate failitüüpide jaoks valmis sellised datakaardid, need väljad, mida sa pead täitma, näiteks kui sul on vaja simulatsiooni failidel sisestada mingit infot näiteks, mis seda eristab, et mingi simulatsiooni tüüp näiteks või autor näiteks või kuupäev, siis selle failitüübi jaoks tehakse datakaardile sellised väljad. Ja pärast on see info siin otsitav. Ehk siis palju erinevaid faile, või põhimõtteliselt kõiki faile, mis arvutis on, saab siia sisse panna, nende jaoks saad need väljad teha, mille peale sa pärast otsid. Need osa väljusid täitub automaatselt, näiteks nagu last save ja sellised asjad, eks ole. Aga mingisugused nimetused pead sisestama ja pärast on need samamoodi otsimiseks olemas. Muidugi CAD-il on kõige rohkem infot, mida see süsteem ise genereerib siia. Näiteks hash drawing selline asi. Seda. On see vastus? Ehk siis võimaliselt kõik failid saab panna. Ja üks huvitav otsingu viis on nimelt otsingu kataloogid, kes on võib-olla kasutanud seda Outlookis mõned aastad tagasi juba tekkinud. Ehk siis sa võid luua otsingu, selle salvestada ja selle salvestuse tulemusi alati kuvatakse sulle kataloogile. Näiteks siin vasakul on mul olemas 2 otsingut. Released kataloogi tulevad kõik failid, mis on releasitud ja siia tulevad kõik, mis on work in progress staatuses. Muidugi sinna juurde saab panna oma nime näiteks või kui sa oled mingi juhtivtöötaja, siis sa otsid mingisuguse kolleegi või tiimi järgi neid nimetusi. Kuid kõik need otsingud, mis me siin sisestame, need saab salvestada ja hiljem siia tulles search folderi peale on seal sees kohe just hetkega need otsitud failid, leitud failid. Revisionid. Nüüd revisionid on väga tähtis teema ilmselt ka praegu. Revisioni ilmselt teete ka käsitsi, sellepärast, et kui disain saab paranduse, siis alati tuleb talle uut numbrit, ütleme, tootmine avastas vea, siis sa teed selle paranduse või parenduse ja sa märgistad selle muudatuse revisjoniga, sellepärast, et mis kuupäeval mingi joonis läks, kõige lihtsam on sellest tähest või numbrist rääkida, milline on see viimane kehtiv revisjon. Nüüd vaatame siin revisjonide loomise funktsionaalsust. Sama detail, mida enne uurisime, tal oli juba paar revisjoni olemas, eks ole, Ameerika kombekohased tähtedega A ja B ja võttes käsu get revision, ma saan siia koos tuua ka vana revisjoni sisse. See on A revision näiteks, antud juhul oli siis värv teine, ma saan niimoodi proovida ja sättida või muuta selle vana revisjoni tagasi. See on ka üks suur mõte, miks revisjoni teha, see võib olla ka selline disaini etapp, et seda uuesti tagasi võtta. Aga nüüd proovides uut revisjoni panna, ma jätsin siia meelega ühe väikse vea sisse. Süsteem ütleb mulle, et fail on lukus, temal ei saa teha uut revisjoni. Nimelt siin süsteemis on revisjoni loomiseks oma selline töövoog või workflow. Ei ole niimoodi, et ma lähen mõtlen, et täna panen talle revisjoni C, vaid selle annab süsteem. Süsteem vaatab, milline on järgmine revisjon ja vaatab, et fail oleks sobivas etapis. Nimelt selleks, et revisjon anda, tuleb ta viia muutmise staatusesse. Praegu on ta locked, ehk siis ta on lukus, ta on nagu heakskiidu saanud ja seda faili ei muudeta. Nüüd selleks, et sellele failile uus revisjon anda, tuleb tema staatust muuta. Staatused on sellised asjad siis, mida omavahel rääkides, näiteks kui me paneme korraks siia pausi peale, siin on võõramakeelsed need asjad, aga kui eesti keeles rääkida, siis work in progress oleks see, mis on parasjagu töö all, ütleme, konstrueerimises, siis for review saadad mingisugusele kolleegile ülevaatamiseks. Ilmselt seda esineb rohkem või vähem, mõnikord kiiruse suhtes seda ei tehta, kui kirjanurgas minust alati on standardina mingi heakskiitja või väli, kus on võib-olla mõnikord see nimi nagu muutumatult sisse pandud. aga mõnikord siiski ei jää vastutust jagada ja mõnes firmas üldsegi ongi reeglid karmid, et tuleb saata kellegi käest läbi, kes vaatab selle üle. Ja siis viimane etapp siin on muide obsoliit. Obsoliit on ka tähtis märkida, et kui tuleb välja, et detail on nagu nii kasutamatu ja ta on juba tootmisest läbi käinud, on juba koostutes sees, aga ta üldsegi ei sobi enam uudesse toodetesse panna, siis märgitakse ta obsoliidiks. Selle mõte on selles, et kui me kustutaksime ta ära, siis vanad koostud ei töötaks ja ta kaoks nagu, kui ma varjaks ära inimeste käest, siis vanad koostud ei töötaks ja ei saaks isegi seda vana vigast disaini näha. Aga kui tal on staatus obsoliit, siis kõik süsteemid teda pärast välistavad. ERP-süsteem välistaks teda, kui tuleks pomm ERP-süsteemi väärtusega obsoliit ja Vault ka ise oskab nüüd seda obsoliiti vaadata ja välistab kui obsoliit. Ehk siis seda koostöö heaks kiita, kui seal on sees mingi detail, mis on obsoliit staatuses. Niisiis selles workflows me valime järgmise sellise etapi, ehk hakkame seda muutmise ringi alguses peale ja selleks on siis work in progress. Ja nagu näete, siin tehtud niimoodi, et kui sa hakkad muutma, muutuse alguses saab detail uue revisjoni. Nii et sa juba muudad uut revisjoni, see on C-revisjon, aga samal ajal see B-revisjon, mis oli heakskiidu, on siiamaani koostuses sees ja igal pool kasutuses. Jah, lihtsuse mõttes teeme värvimuudatuse ja paneme tagasi süsteemi check-in'iga. Check-in on siis selleks, et ma lõpetan töö enda juures ära. Minu jaoks muutub see file read-only'ks, annan selle süsteemi ehk PDM-süsteemi kätte. Ja tänu sellele, et ma panen ta serverisse, annan õigus ära, saab järgmine kolleeg seda, mida nüüd lahti võtta, vaid ka edasi muuta, kui tal peaks vaja olema. See hüppas nüüd siin ajaloo puusse kõige alla. Ja nüüd ei ole muud üle, kui see revision saata review'sse, ehk siis ülevaatamisele ja hiljem ka siis lukku panna, ehk siis heaks kiita. Antud juhul ma teen seda ühe kasutajal, aga muidugi mõnikord tehakse seda erinevate kasutajate all. Nüüd, kui me vaatame siia neid seadeid, siis me saame näha, kuidas on need elu ja kaared ehitatud üles. Näiteks, kui valida detaili tüübiks engineering, siis siin on näha need etapid, mis tema heakskiiduks saab kasutada. Ja kui te nüüd vaatate, siis siin ongi märgitud, et see obsoliit on süsteemi jaoks eraldi selline etapp, mida ta välistab ja ei luba kasutada kuskile süsteemi edasi saatmiseks. Ja siin on näha revisjonisüsteem, engineering tüübi detailidele on revisjonisüsteem näiteks tähtedega A-st kuni kuhu iganes tähestik välja jõuab siis. Ja.
Mis on õigesti aru, et kogu siis see heakskiiduprotsess läib aastane revisjonide ajalugu, et see on ainult Vault passion'id omad Vault basic.
Jah, see võiks küll nii olla, jah. Ja pärast tuleb veel üks suuremaid asju välja, nimelt pommi selline, nagu ütleme, korralik pommi haldus tuleb ka professionalis alles. Aga vähemalt mingisugune heakskiidu või staatuste määramine minu meelest on basicus ka olemas. Niisiis järgmine teema on jälle muudatused. Või vabandust. Tark kopeerimine, tahtsin kopeerimist rääkida. Nimelt, kõige suurem õnn võib olla see, kui teil on olemasolev disain, mis tuleb uueks kopeerida. Aga sellisel juhul kindlasti mingid detailid on need, mis tuleb siis kliendi kohaselt või uue soovi kohaselt modifitseerida, aga mingi osa asju läheb uuesti kasutusse. Nimelt siis PDM-is, Vaultis on võimalus seda päris võimsalt teha, valides siis selle koostu, hüppame siia Vaulti aknasse, saame käivitada disaini kopeerimise käsu. Nimelt siin me saame siis iga detaili vahel teha detaili juures teha sellise targa otsuse, kuhu me ta kopeerime ja kas ta saab uue numbri, uue nimetuse uue asukoha või teda üldse ei tule siia koostöö sisse. Siin ma teen uue kataloogi siis selle koopia jaoks ja kui ma ühe detaili sinna määran, siis süsteem järeldab ise, et ilmselt tuleb see koost ka kopeerida. Niisiis, üks detail sellest koostust tuleb kaasa, aga selle viimase jätan üldse välja. Ehk siis mul on võimalus selle koost niimoodi kopeerida, et üks detail, mis praegu seal nagu sees on, jääb üldse ära. Siin ma teen käsitsi nummerduse, kuid selles Vault süsteemis on väga võimsad nummerduse süsteemid, nummerduse defineerimissüsteemid. Saab isegi erinevates keeltes tekste, ütleme, nimetusi üles ehitada, et kui sa valid näiteks nimetuseks midagi inglise keeles või eesti keeles, siis ingliskeelne väli ja saksakeelne väli saab täidetud. Aga samamoodi numbrid on väga targad, kuid siin lihtsuse mõttes panime käsitsi ja kopeerisime selle koostu nüüd uude kohta. Ja kui me seda vaatame, siis me näemegi, et siin on üks detail puudu. Siit seest koostust on üks detail puudu ja üks on vana nimega ja üks nendest sai uue nime. Et siia tuli siis üks, mis on uue nime ja üks nendest on vana. Suurte koostude puhul, kus on sadu või tuhandeid komponente, kus on kinnitusvahendid, mingid ostuosad, siis selliste kopeerimistega vahepeal käisid läbi ka see koht, kus saab reegleid luua, kus sa saad määrata, et kui sa kopeerid, siis ära ostukomponente dubleeri, ära kunagi kinnitusvahendid dubleeri. Nii et saad luua reeglid, missugused komponente üldse saab uue numbriga kopeerida kuskile. Koostöötamine. Kindlasti üks PDM-i suurimaid kasusid on selles, et saab koos teha tööd sama koostu kallal ja tema ülesanne on siis garanteerida, et iga detail on kellegi käes ainult ühekordselt. Ta kannab sellest hoolt, et inimesed teaksid, kellel on õigus mingit detaili muuta ja kes peab ootama siis kuni vabaks. Näiteks siin on väga lihtne näide sellest, kuidas üks kolleeg muudab detaili värvi, materjali ja demonstratsiooniks teine kolleeg on lausa teise värviga sellises nagu interface'is, kus temal on juba näha siis selle detaili revision ja teine värv nii-öelda. Muidugi see asi tuleb kõige paremini välja inventori sees töötades. Osaloetelu haldus. See on see koht, mis tuleb võimsalt sisse Vault Professionaliga. Nimelt ma mäletan seda, mul on see hetk meeles, kui ma insenerina tegin oma esimese mudeli valmis, joonise valmis, mis printsin välja, võtsin heakskiidu ka, ja siis ütles mulle nagu muu seas see, et aga nüüd osaloetule ka. Siis meil polnud koolis räägitud üldse midagi sükest nagu ERP-st. Ajad olid muidugi teised ka, siis mul tuli välja, selgus, et mingisugune tunnikene veel on vaja toksida, kopeerida, pasteerida. Ma ei tea, kas siis sai üldse kopi võtta kuskilt käedis, pidin kirjutama mingid numbrid teise süsteemi, looma osaloetelud. Ehk siis see töö läks veel edasi. Kaasajal on hästi palju ERP-süsteeme erinevad, millesse saab infot sisse tuua automaatselt. Ja kui siis nüüd me CAD-i nagu faili paketti vaatame, siis tavaliselt on detail ja joonis, koost ja joonis. Enamasti neist tehakse PDF või DVG ka mõnest joonisest, kuid põhiliselt on paaris. Kuid nüüd, kui me vaatame siis tavalises PDM-is Vault Basicus seda pommi, siis ta näitab seda sama pommi, mis on meil olemas CAD-is, ehk siis positsioonid ja kogused ja seesama tuttav, see on tegelikult pommi analöög, see näitab, et mis siia sisse käib. Kui me pommi puhul nägime seda, mis on positsiooninumber ja kogus, siis on üks vaade veel, kus me näeme lihtsalt seda nagu komponenti, mis sellesse pommi käib. Siin ei ole koguseid, aga siin on sellised PDM-i spetsiifilised infoveerud. Ja muidugi were used, kui valid detaili, mis kuskile kuulub või alamkoostus, siis sa näed tänu sellele andmehaldussüsteemile kohe, kuhu ta veel kuulub. Nüüd, mis meile annab juurde Vault Professional? Nimelt Vault Professionalil tuleb sisse termin nimega item ja itemiga saab nagu reaalselt elu paremini kas simuleerida või siis järgi viia. Sest lisaks joonisele ja mudelile võib käia selle detaili või selle komponendi kaasas palju rohkem elemente. Näiteks G-kood, muidugi PDF, TVG, võib-olla mingisugune spek, võib-olla mingisugune juhend, ehk siis kõik, mis seda kirjeldab tegelikult, kuuluvad tema juurde. Neil võib tulla isegi erinevad numbrid, erinevad asukohad, aga sisuliselt nad kirjeldavad seda sama disaini, sama reaalse elu komponenti ja siis item on selline termin, millega saab nüüd kokku siduda. Ja samamoodi on ka koostöö puhul, kus on mingi pakett asju, mida siis itemiga saab siduda kokku. Ja järgmisena me vaatame, kuidas Vault Professional siis nende itemitega aitab meil toimetada. Nimelt me võtame selle sama koostöö ja loome kõikidest CAD-i dokumentidest itemid. Siin saab ka valida erinevaid tüüpe ja see nüüd on selline siis, kui CAD-is meil on suht üks ühele nii ühikud kui ka materjalid kui ka kogused, siis siin nüüd saab mingisugune võib-olla isegi lausa ostusspetsialist või tootmisspetsialist lisada uusi elemente, miks mitte näiteks siin lisada mingisugune võib-olla liim või siis hoopiski mingisugune protsess, võib-olla pannakse siia sisse juba protsess nimega pakkimine, kvaliteedikontroll, miks mitte, eks siis selle tootega võib panna igasugust infot kaasa, mis tegelikult päris elus, aga nagu loogiliselt vaatame, et käib kaasa, aga mida CAD ei võimalda. Nüüd, kui me lõime need itemid, siis PDM annab meile võimaluse selle targa pommi nüüd siis eksportida. Siin on see koost, kõikidest on itemid loodud ja nüüd meil on võimalus see eksportida mitmesse erinevasse viisi ja pange tähele, siin on võimalus nüüd näha seda, kuidas PDM teeb vahet sellel staatusel. Näete, siin on kirjas, et luba eksportida ainult reliisitud või siis obsoliite asju. Eks reliis tähendab seda, et see on saanud heakskiidu, keegi on selle üle vaadanud ja see on nagu lukku pandud, seda enam ei muudeta. Või siis obsoliit on ka selline komponent, mis kindlasti peab jõudma AruCAD Süsteemi, et laos midagi ette võetakse või tellimustega midagi ette võetakse. Ehk siis vaikimisi see süsteem võimaldab ainult neid asju välja võtta. Aga muidugi ma võin see linnukese siit ka maha võtta demonstreerimise pärast ja võin saata ka nii-öelda tooreid ehk siis heakskiiduta faile välja. Siin on meil valida XML fail, CSV fail, sõltub, kuidas meie järgmine süsteem, mida ta sööb. Ja valime siis parameetrid. Nimi, number, positsioon ja kogus ja mida iganes veel. Meil on vaja siis AruCAD Süsteemi saata. See saab kõik salvestada ja muidugi selle saab panna ka automaatselt taustal tööle. Ja pärast eksporti tuleb meile selline ilus tulemus, sõltuvalt sellest, mis süsteem meil on, kuidas ta seda Excelit tahab süüa, selle saab tema jaoks sellisel moel valmis teha. Ja nüüd me jõuan jutuga tagasi sinna, kuidas ma algajana siis kuulutasin tund aega, et seda osaloetavalt kuskil süsteemis sisse toksida, siis nüüd võib see toimuda lausa taustal ilma selleta, et ma midagi teeksin. Kui ma kiidan oma koostöö heaks, on heakskiidu, siis visatakse see XML või Excel kuskil välja ja teine süsteem saab selle üle võtta ja järgmisse süsteemi importida. Ülevaatus ja heakskiit. Ma olen rääkinud palju kordi siin sellisest heakskiidust, kuidas keegi vaadab joonise üle ja ütleb, et approved või siis rejected. Aga Vault Professionalil on ka nii-öelda reklamatsioonide haldamise süsteem, mis hakkab sellest peale, et on mingi probleem vaja lahendada, midagi on, kas võib olla kas või uue disaini tegemine, aga võib olla ka olemasoleva parandamine, kus pannakse valmis infopakett see on vaja parandada, siin on see mail, siin on see mingisugune dokument veel, siin on mingid pildid, pannakse see pakett valmis ja valitakse inimene, kes seda hakkab tegema. Ja selle mõte muidugi võib seda asja kõige e-mailist võtta ja võid öelda ka lauanurga peal istudes, et võta see nüüd sealt ja võta see nüüd sealt, aga PDM-i mõte on selles, et see on product data management. Info jääb siia süsteemi. Kui aasta pärast keegi küsib või klient vajab ülevaadet, mis te meie jaoks teinud olete, siis see alginfo, mis anti, mis põhjendab seda muudatust, on siin süsteemis kõik sees. See ei ole enam kellegi mailboxis või mingisuguse või siis paberi nurga peal mingi kritseldus. Tehes seda parendus või seda muudatuse tellimust saab panna ka kuupäeva, muidugi mõttekas panna mitte homset, aga saab panna inimesele kuupäeva, siis kui see kuupäev saab kätte, siis tal on nagu mingisugune eesmärk olemas ja võimalus, et ta näeb seda ka väikse punasena, kui ta üle läheb. Siin on väike heakskiiduring blockscape'ina, millisel moel siis heakskiit käib. Loodan, see teid ei hirmuta, sest tegelikult seda kõike saab palju lihtsamaks teha ja see pea üldse tegema teie elu keeruliseks. Seda võib kasutada ja selle kasutamist saab alati teha teie jaoks sobivaks. Nüüd on siis näha, et valiti inimene, kellele anti infopakett, paluti see muudatus ära teha. Nüüd on juba järgmise inimese käes, ehk siis seesama insener sai selle kätte ja ütleb, et lähme edasi sellega. Vabandust, see on just see hetk, kui pannakse alles tellimus. Valiti inimene ja pannakse kirjeldus, et palun tee see, vaadata see infopakett üle ja tee see korda. Nüüd järgmine logib sisse tööetapis, kui insener tuleb tööle, temal on siin worklist ees. Väga lihtne vaadata, mis talle on ette pandud teha. Ta võtab selle paketi lahti, vaatab, mis vaja teha on ja asub toimetama. Antud juhul siis paluti talle murvad ära faasida. Töö lõppenud, nagu ikka PDM-is check-in, siis läheb info tagasi süsteemi, jääb kirja, kes tegi, millal tegi, mingi kommentaar ka ja siis sellele töökäsule, ehk siis parandustöökäsule paneb ta märkuse, et võib edasi minna. Nüüd järgmisena logib sisse või saab teavituse siis keegi kolleeg, kes töid üle vaatab. Temal on samamoodi worklistis siin engineering change order ja temal on siis ülesandeks seda üle vaadata. Ehk siis selle mõte on see, et sa ei pea mäletama või lugema meile, kus sul on 10 meili või 100 meili seas on küll 10 sellist, mis ütlevad, mida sa pead tegema või siis kuskil kokku korjama. Ülesanne pannakse ühte paketi kohale, kõik on, üks tööülesanne on ühes objektis, sa võtad selle lahti, kogu info on ühes kohas olemas. Ja nüüd kogu see workflow käis läbi ja jõudis close'ideks siis suletuks. Ja selle mõte on siis selles, et nüüd seda enam muuta ei saa. Selle protsessi jooksul tehti muudatusdetaili, mis sai uue revisjoni või mingisuguse uue välimuse koos revisjoniga. Aga nüüd see info, kuidas ta käis läbi, kes tegi, millal, kui kiiresti, see jääb ka süsteemi alles. Ja kuidas saab jagada andmeid väliste kasutajatega? Kindlasti on väga levinud süsteem, levinud kombestik saata meilidega, PDF-e ja DVG-sid, kuid mõnikord on vaja lihtsalt välimust jagada kellegiga vaatamiseks. Ja selleks on võimalus kasutada sisseehitatud süsteemi, mis paneb selle faili sellisesse nagu vieweri keskkonda. Saame nagu valida, mida me sinna edastame ja tõesti see läheb minutiga, võtab mõne minuti ja siit me saame lingi, mis me saame inimesele, sellele vaatajale saata. See on unikaalne, isegi sisse ei pea logima ja siin saab vaadata, lõigata, mõõta, keerutada. Ja peab ütlema, et detaili tuleb, see on lihtne funktsioon, detaili tuleb saab saata ka jooniseid, aga need tuleb siis ükshaaval selleks valida. Ja nagu näete siin, siis on võimalus tavalisi manipuleerimisi kasutada, mis on vajalik, et mingit kellegi faili või joonist vaadata. Ja muidugi on olemas mobiiliäpp. Siin on näidiseks üks töövoog, kuidas mobiili kaudu saab lisada, või no see on tahvel tegelikult, saab lisada sellise töökäsu kellegile. Võib-olla inimene tahab teha tööd kuskil lennajamas, võib-olla diivani peal, võib-olla objektil, miks mitte tuleb välja, et midagi on vaja kiiresti parandada. Võtad tahvli välja, otsid üles süsteemist selle komponendi ja teed kohe töökäsu. Sul on vajadus siis see ava eemaldada. Kui sa juba tahvliga kuskil tehases möllad, siis sa võid saata ka pildi siia juurde sellest, mis on vajadus seda tööd teha, mis on selle muudatuse vajadus või alus. Ja siin taustal näete, on Vaulti aken lahti. Nii et kui see töö siia lisatakse, siis ta ilmub kohe ka meile siia Vaulti. Change order ehk siis selline töökäsk, millesse lisame selle faili, millele pandi just kommentaar. Ja attachmentiks näiteks mingisugune seesama foto, mis tehti selle kirjeldusega. Juba me tähele, see engineering change order tekkis kohe sellele, kellele see pandi, tekkis kohe süsteemi. Ja temal ei ole muud üle, kui see asi lahti võtta. Palve ja töökäsk on sees ja nii kiire see ongi see ava eemaldamine ja lõpuks on see töökäsk jälle closed etapis. Ja uus revision ilma avata on siin. Ja samamoodi saab siis ka kolleeg oma tahvlis vaadata kohe seda tulemust. Ja ühena viimastest näitan viisi, kuidas käib PDM-is juurdepääsu kontroll. Nimelt me oleme rääkinud siin workflow'st. Ja workflow üks mõte, esimene suurem mõte näidata, mis staatuses fail on, kas ta on töö all, kas oodab heakskiitmist, kas ta on lukus või valmis. Ja ilmselgelt sel hetkel, kui ta ootab heakskiitmist, seda ei peaks keegi enam muuta saama. Sest et ta on juba kellegi laual, selleks hetkes on ta lukus. Samamoodi sel hetkel, kui ta saab heakskiidu, kui ta läheb tootmisse, kliendi juurde, ka sel hetkel on lukus. Ehk siis see workflow on siin selleks, et kontrollida juurdepääsu õigusi. Siin on väike kiire ülevaade siis, kuidas käib nende õiguste panemine. Nimelt siin on ette loodud päris palju selliseid rolle, mis garanteerivad selle, et süsteemis on sinu jaoks olemas kõik valikud ja sa ei pea nagu mõistatama ja testima, missuguste õigustega peab keegi kasutaja siin süsteemis töötama. Näiteks siin loome uue kasutaja, inseneri, valime, mismoodi ta sisse logib, teeme talle ainult Vaulti jaoks konto. Ja siin on näha siis nimekiri sellistest õigustest. Kui me korraks siin pausi teeme ja vaatame neid, siis me näeme, et päris mitmest õigusest on 2 variatsiooni. On nii vaatajad, administraatorid, on managerid, igasugused tegelased. Need ei ole väga keerulised, ses mõttes igal õigusel on paar rida kirjeldust juures, kõik on helbis olemas. Ja see, et nad on teie jaoks valmistatud, annab teile väga suure mugavuse ja võimsuse selle süsteemi konfigureerimisel, uue kasutaja loomisel ja talle õiguste andmisel. Antud juhul siis lihtsalt mõttes pandi küll administraatori õigused, kuid kui nad on insener, siis on tal vaja ainult ühte õigust, mis lubab check-out'i teha ja check-in'i teha. Ja siin on üks kasutaja, kellele pannakse siis kõik õigused. näiteks change requester, notification user. Notification user on selline kasutaja, näiteks võiks olla tootmise esindaja, kes saab vastavatest muudatusest omale kohe teavituse emaili peale. Kui mingi revision tekkis, teda huvitab see, et kontrollida, kas see toode võis juba tootmises olla, siis igast muudatusest võib selline inimene saada kohe teavituse. Ja see on üks huvitav koht, see message. See tähendab seda, et konsensuslikku ja võtame teise võõrsõna, et konsensusliku heakskiidu võimalus on kasutamata. See tähendab sellist võimalust, kui teie disainis või koostus on mitu spetsialiteeti. Kõige lihtsam on ideaalsemalt see, et on olemas mehaanika osa, elektri osa. Ja sellisel juhul on vaja, et heakskiiduks vaataks üle mehaanikakonstruktorid ja vaataks üle ka mingisugune elektroonikaspetsialist. Ja unanimous. Ehk siis mitme kasutaja samaaegne heakskiit on võimalus üles edada siis, kui teil on vaja, et mitme osakonna spetsialistid, mitu erinevat inimest annaksid heakskiidu ja see saab heakskiidu ainult, läheb edasi ainult sel juhul järgmist etappi, kui kõik need inimesed, kes selles protsessis on, annavad selle heakskiidu siis. Nii et mehaanika inimene ei vastuta elektroonika eest, elektroonika ei vastuta mehaanika poole eest. Ja ma ei tea, kuidas nagu mul nüüd ajaga on. Täpselt väga hästi. Siis on hea. Püüdsin hästi kiiresti rääkida, sest et infot oli palju. Ja kas oli ka... Jah, palun.
Mis on põhieelnevus Autodeski Vaulti ja selle tootmisprotsesside?
Põhilist erinevust ei ole. Devilis in details.
Näiteks solitokspädent töötab päris tihe Windowsi Exploreriga. Aga siin on eraldi application.
Ja, see on suur erinevus. Selles aken on palju kirjum, siin on rohkem funktsioone, aga ma võiksin öelda, et põhiasjad on mõlemal kaetud, ehk siis workflow, engineering change order on tal eraldi välja, see on eraldi funktsioon, aga PDM-süsteemid on kõik nagu sarnased, need annavad check-in'i, check-out'i, annavad pommi funktsionaalsuse, annavad võimaluse erinevad revisjoni uuesti välja vahetada, vaadata latest ja vaadata mingit koostuni, kuidas ta tehti mingi ajahetkel minevikus. Ehk siis need põhiasjad on kõigil olemas ja muidugi siin ka väga rikkalikult.
Siin sellist veebi juurdepääsu ei ole, et koostööpartnerid on osapooled, kes ei ole otseselt selles firmas, aga kes vajavad seda infot, tahavad teha päringuid erinevate tootmisversioonide osas, mis on komponendid näiteks. On mingid müügiinimesed, kes näiteks firma arendatud toodet peavad edasi müüma. Ma ei pea nägema kõiki detaile, aga mingid osa sellest midagi päringud.
Seal on kaks varianti. Praegu ma näitasin siin seda tahvli varianti. Selleks on olemas äpp, eks ole. Eks see eelis on see, et äppi installeerimine on väga lihtne, ei pea arvutisse administraatori õigusi omama ja see on üks variant, kuidas kergesti anda juurdepääsu. Ja siis muidugi õigustega saab piirata tema juurdepääsu, mis asju ta vajab, mis kataloogi ta näeb, mis projekti ta näeb, on igal juhul. No see on põhiline, kui sa teed mingi kasutaja, sa määrad, mida ta näeb. Nüüd, mis vahendiga ta võiks veel näha, on teine variant, on see sama Vault. Selle Vaulti installimine on ka üks võib-olla kõige lihtsam või kõige võimsam variant. Ehk siis sellel aastal tuli, või viimase versiooniga tuli Vault välja sellise analoogiaga, kus ta pakub sellist puhvri võimalust, nimelt läbi nende serveri ühendamist teie serverisse. Kui muidu sul oleks vaja VPN-i, kõiki kasutajaid, konfimist ja nii edasi, et saada sinu serverisse ligi, üldse, kui keegi üldse lubab seda teha. tehniliselt on seda ka keeruline teha või palju vaeva, siis tänu sellele puhvrisüsteemile sa saad inimestele teha konto, luua see unikaalne puhver ja kui nad installeerivad omale selle Vaulti kliendi, siis see ühendus käib läbi selle puhvri, ilma et nad peaksid VPN ühendust looma, süsteemi kuidagi moodi kontosid looma, nagu kaasajal käib, eks ole. Ehk siis ma arvan, see puhvrisüsteem läbi interneti ligipääsuks on kõige lihtsam ja mõttekam. Edasi tuleb muidugi, neil on litsents vaja anda ja neil on vaja see installeerida.
Ilma litsentsid ei saa ligipääsu.
Ilma litsentsita ainult oli see tasuta viewer, mis ma näitasin, see oli väga selline lihtne.
Kuidas see litsentsi poliitika toetab seda, et PDM-süsteem on teiste dokumente ja teise projekti liikmed pääsevad ligi mitte ainult insenerid, siis tähendab, et kõikidel projekti liikmetele tuleks osta täislitsents koos saaks lihtsam autodega litsentsid.
Kõige spetsialist on seal tagasi litsentsidest räägib, aga põhimõtteliselt on endiselt võimalus see, et kui sul on võrgu litsents, mingi ports litsentsi ja kes sees see mees. Ja mingist mõttest on kasulik teha inimesele see nimeline litsents, eks ole, kõik sõltub nagu hinnast. Aga ma ei ole nii spetsialist rääkima neist variantidest, seal on nii palju uuendusi ka.
Sujami käib väga selgelt käed Vaultis. Kõik ülejäänud on enda serveris sellepärast, et oleks ligipääs kõikidel.
Nojah, ilmselt teil on mingi server või teil on OneDrive näiteks, see maksab palju vähem, et need on need dilemmad. Muidugi asi läheb palju lihtsamaks, kui kõik panna PDM, eks ole, kõik on seotud. See on üks suke hüpe, sest kui sa juba paned kõik kontoriinimesed ka PDM, ega keegi sealt enam välja tulla ei taha, tagasi sammu enam ei ole. Aga enne seda lükket tundub see investeering nii suur ja nii luksuslik, eks ole. Et see Vault Office, eks ole.
Ma ei tea, kas saab palun lühidalt markeerida seda küsimust, mis oli Vaulti ja Fusioni seos, et me nägime Vaulti inventoriga koos töötavad ilusti. Et kas on seal midagi või tegelikult ei tööta koos?
Ja seda vastab kindlasti pool vastaks hästi sellele. Et sama nimiga erinevad tooted, eks ole. Ma ei ole ka sellega kursis. Aga kui ma tahtsin seda veel öelda, et kui see tundus keeruline, siis pole hullu, selleks oleme meie siin, et meie sellest keerulisest teie jaoks läbi hammustame ja asi lihtsaks teeme.
Okei, suur tänu, Mati, väga põhjalik ettekanne oli, korralik detailsus, et ühtlasi oleme me tänase päeva jooksul teie peaksid korralikult täis tagunud ka uut informatsiooni, et sellega ametlik osa on läbi. Veel kord küsime publiku käest, kas midagi sai teile veel segaseks jääda üldse? Et soovib keegi kommenteerida, parandada veel kord. Vaatame, milline meil online aktiivsus on. Terje, oskad sa kommenteerida? Küsimusi ei ole, siin on ka öeldud, et kõik on jumala selge. Tegelikult ei ole. Aga okei, ma võtan pildi ka veel korra ette. Nii, share screen, lubage mind korra. See nupp, vabandage, päeva lõpuks hakkab endaga meelest ära minema. Sellisel juhul on kõik, et täname, et osa võtsite, täname, et vastu panite. Sama kehtib ka veebis osalejate kohta. Enne kõike loodame, et saite midagi tänasest päevast. Kui muud ei saanud, siis saite teada, kust infot juurde küsida AruCAD Süsteemidest, kõikide asjade kohta. Ja jälle kohtumiseni järgmise korrani siis.